This is the famous Helix Nebula, a planetary nebula formed by a star not so different from the Sun that at the end of its lifetime released a huge amount of gas, leaving behind a white dwarf. A white dwarf that's still visible in the center and that actually has been studied by a lot of different astronomers over the years. And extremely recently, in March of 2025, researchers actually discovered that the unusual X-rays coming from the center of this nebula seem to be the result of an ancient planet destroyed by the central white dwarf, possibly not so long ago, essentially confirming that these unusual X-ray signals that were first detected over 40 years ago seem to be a direct confirmation that this object used to have a planet that has since been shredded and destroyed and potentially became some kind of a ring. And naturally, this is not the first and not the last time we're going to be seeing signs of ancient planets around white dwarfs. As a matter of fact, the majority of white dwarfs seem to contain something. Usually the signs of an absorbed or a destroyed planet, sometimes rings, but in some cases researchers also discovered actual white dwarf planets, with one that was recently analyzed basically becoming a new record holder. And so, hello wonderful person, this is Anton. In this video we're going to discuss a relatively recent study and a somewhat recent analysis using the James Webb Space Telescope, reported in a study by Mary Ann Limbach and the team you see right here in April of 2025. And here this was an additional observation based on a discovery from 2020, a system known as WD 1856 plus 534, actually a triple system containing two red dwarfs and an orbiting white dwarf, was discovered to have a really bizarre planet. And because this is only about 80 light years away from us, this was a super exciting discovery, because in this case, this planet was far enough from the white dwarf that it could now be directly observed. But before we discuss exactly what was discovered here, the first question here is, why exactly does this matter and why is this important? Well, as you probably know, today most of the exoplanets have essentially been discovered using the method right here. This is the transit method, a method where you basically look at a star and then try to discover shadows passing in front of a star with a regular interval. This is how the majority of planets so far have been discovered around pretty much most of these star systems. But these shadow observations don't really tell us much about the planet themselves other than their size. And though it is possible to sometimes analyze their atmosphere by looking at the region where the starlight passes through the atmosphere of the planet, this is an extremely difficult method. And so trying to identify the emission spectra of the actual planet, or to be more specific, trying to identify what kind of an atmosphere they might have, so far has been sort of challenging. So we know that these planets are there, and we know their size and sometimes their mass, but not what kind of planets they are, what's on their surface, or if they can be habitable and maintain stable conditions. Which is why scientists have actually been trying to discover a better way for direct imaging, physically looking at different planets and trying to find out what kind of light is coming from them in order to then find out what's in their atmosphere. But detecting direct light is super challenging, and so far only some planets have been seen this way. Here from this simulation you can see that it actually involves something known as the coronagraph, which essentially blocks the starlight, while also allowing us to study the star's corona. But most of the planets this has been applied to are usually very far from the star and are extremely different from anything we have in the solar system. And so basically this only works for gas giants in extremely wide orbits, but also usually with very high temperatures in the atmosphere, because this is the only way these planets become visible. Cold planets are extremely difficult to find, even if they're far from the star. And to date, not a single rocky planet has been observed directly, mostly because usually they orbit much closer to the star, or are essentially invisible if they're farther away. Moreover, not a single exoplanet that's colder than about 275 Kelvin or about 2 degrees Celsius has been seen at all. And that's because usually colder planets are super difficult to find using any of the telescopes, and basically because they don't produce enough infrared emissions. But we obviously know such planets should exist, and we also know that it should be possible to observe something once we discover the right environment. And here, white dwarfs actually present us with a perfect opportunity, mostly because white dwarfs by nature are extremely dim, but also dense enough to contain a planetary system that can actually stay stable for a pretty long time. As a matter of fact, in some of the previous videos about white dwarfs, we've discussed some of the more unusual discoveries when it comes to planetary objects, and some white dwarfs that actually do have some really strange systems. But more importantly, since white dwarfs are so small and so dim, they generally reduce the contrast by so much that it makes a lot of objects in the white dwarf system stand out quite a lot. In other words, allowing us to see any object, assuming we have a powerful enough telescope. And in theory, if we could somehow detect a planet around a white dwarf and we could actually see it directly, it could then present us with a perfect opportunity to study everything about planetary evolution and to discover what happens to various planets once stars like our Sun essentially turn into white dwarfs. For example, can planets even survive this stage? And if so, what do they become? And I guess even more importantly, can a typical white dwarf system at some point potentially become habitable? We've discussed this idea in some of the previous videos, but so far all of this has been kind of hypothetical. We know that these planets are possible, we just don't really know where and how. And so let's discuss this new study and this new discovery. First of all, this of course involves the James Webb Space Telescope, the most powerful infrared telescope scientists currently possess, and a star approximately 80 light years away in the constellation of Draco. But in 2020, this system was confirmed to contain a planet. If you go online and if you try to find this planet inside the NASA Exoplanetary database, here's roughly what this star system looks like. And this region right here, that's the so-called habitable zone. Now, even though NASA in this case reports the star as a K-type star, which technically this object kind of is, in reality this is a white dwarf that's basically much colder than usual. In other words, this is actually a white dwarf that's really old, possibly at least 6 billion years old, and as a result, its temperature is approximately 4400 degrees Celsius, 8000 Fahrenheit. In other words, it's technically much colder than the Sun. But surprisingly, it also contains a planet in a very tight orbit. Here it takes approximately 34 hours per orbit, which already kind of presents us with a mystery. It's not entirely clear if this is a planet that used to exist here from the beginning, and if so, it's unclear how this planet survived the expansion of the star before it became a white dwarf, or if this is an object that formed from some kind of a remnant that existed around this white dwarf, such as for example some kind of a ring. So for all we know, this is actually a new generation of a planet formed from some kind of an ancient planet that became shredded over time. Either way, we know that this system is just a little bit unusual. For example, the white dwarf itself seems to be relatively rich in hydrogen, with a total mass of about 60% of the Sun, and it could be as old as 10 billion years old. So basically we know that this is an ancient system. That's the only way we can explain such a low temperature. But based on its mass, we know that this is very likely a star that was very similar to the Sun. So in some sense, this actually shows us what might happen to the solar system 6 to 7 billion years in the future. But we also know that this white dwarf at some point was very likely much hotter, which means that this habitable zone was expanded much farther away as well. And that means that at some point in the past, this unusual planet could have been in a habitable zone as well, which of course makes this a super exciting object. And so when this was discovered in 2020, this was the first ever officially confirmed transiting exoplanet around any white dwarf, which allowed researchers to work out a lot of properties of this planet. But there was one property that was missing and researchers really wanted to know about: its temperature. Scientists wanted to find out how cold or how hot this object is, especially since it's in such a tight orbit to a somewhat unusual cold white dwarf. And obviously they wanted to find out everything else about it, including its mass. Initial observations assumed that this was about 13 to maybe 14 masses of Jupiter, suggesting that maybe this was actually a brown dwarf, but this was based on some of the preliminary evidence. And so now, based on this study, researchers worked out pretty much everything by using a very detailed observation from the James Webb Space Telescope. Here, by using observations in the mid-infrared, or using MIRI, they basically confirmed that this is the coldest exoplanet ever seen. Here it seems to have a temperature of about 186 Kelvin, minus 87 Celsius, minus 125 Fahrenheit, which is slightly warmer than the overall temperature in the upper atmosphere of Jupiter, but definitely much colder than any exoplanet we've seen so far. It's also obviously much colder than Mars. At the same time, the observations here confirm that this planet is about 6 times mass of Jupiter, so basically much lighter than previously assumed, with the observations also confirming that this planet is indeed orbiting very close to the white dwarf, and exoplanets seem to find a way to survive around white dwarfs billions of years after a typical star becomes a red giant, with the new observations suggesting that the star system is at least 9.3 billion years old and basically exists inside what's known as the forbidden zone of white dwarfs, the region where we don't think planets should exist because they should be shredded apart. And so not only is this a confirmation that James Webb is able to detect exoplanets much colder than anything we've seen before. It's also able to detect objects colder than brown dwarfs and objects in orbit of white dwarfs. And even though this planet is actually pretty far away, even for the James Webb, it was still able to detect it despite relatively cold temperatures and the distance. And here it only took approximately 1 hour. Although here these observations still do not answer some of the other important questions. Why does this planet even exist? Now, some of the additional observations might reveal some other planets that could explain some kind of a migration from the outskirts closer to the white dwarf, or possibly find signs around the white dwarf that this is actually a result of a second generation of planets formed from the disk. But I guess more importantly, future observations, especially the ones that are being conducted right now in the near-infrared frequencies, will also help us determine what's inside the atmosphere. So basically the future study here will tell us more about the planet's atmosphere, helping us figure out if at any point in the past this could have actually been a somewhat habitable world, or at least have conditions where life could have maybe formed somehow. Once again, because in the past the habitable zone was actually much farther away, and so this planet could have been much warmer. Now obviously this is a gas giant, and so the chances for life here are somewhat minuscule, but still worth exploring. Which means that in the next few months we're going to get some of the chemical analysis as well, and discover the chemical signatures from this bizarre cold planet. And if by some chance we discover things like oxygen, nitrogen, methane, water, and possibly some other chemicals, especially organic chemicals, this will suddenly become way more exciting. It might actually turn into the first ever white dwarf planet with potentially habitable conditions. But once again, you can explore this idea a little bit more based on a previous study and a video about this that you can find in the description below. But in general, since in the future approximately 97% of all stars in the Milky Way are actually going to become somewhat similar to this, they're basically going to be white dwarfs, trying to figure out if such planets are possible and if habitable conditions are possible as well, can tell us just a little bit more about what's going to happen to life in the Milky Way galaxy.
Hello wonderful person, this is Anton, and today we're going to discuss a discovery of one of the most extreme planets we've ever seen, at least in terms of atmospheric conditions and the speed of the wind. Because for the first time ever, researchers have discovered the planet with the fastest winds ever. Average velocity of about 9 km per second or 33,000 km per hour, which is kind of mind-blowing. And so let's talk about this discovery and this planet in a little bit more detail, because it is bizarre for a lot of other reasons as well. But I guess first, where is this, what is this, and what do we know about it? Well, up until a few years ago, most of the research basically focused on measuring mass and radius of various planets in order to determine their density and to then basically figure out what sort of a planet this might be. But this only gave us a very limited observation because it was extremely difficult to measure atmospheric conditions or the actual composition of the atmosphere, which would help us determine what sort of a planet this actually is. And well, something like this was done back in 2016 with the discovery of this planet known as WASP 127b. Its size and its mass were calculated relatively accurately, but we basically knew nothing else about it. But even back then, this already classified as a somewhat unusual planet. Now, first of all, this was a gas giant, kind of similar to Saturn in mass, but actually bigger than Jupiter in size, which sort of made this planet what's known as a poofy planet. A type of a gas giant with a very expanded atmosphere that even today still doesn't really make sense. On top of this, it was orbiting a G-type star, very similar to our Sun, but because it was over 500 light years away from us, everything else was a bit mysterious. But because this was a poofy planet passing in front of its star, it allowed researchers to basically study everything about it in order to maybe solve the mystery once and for all. Basically, what makes these planets so large, and what makes them different from planets like Jupiter and Saturn. And over the years, there were quite a few observations with various telescopes, including the European Southern Observatory's Very Large Telescope, which might provide some hints on why this planet is so inflated. And so in the last 8 years, there were discoveries of sodium, potassium, lithium, and actually quite a lot of different metals in the atmosphere, with additional confirmations that this planet was tidally locked and it was obviously pretty hot. Over 1000 Celsius, approximately 2000 Fahrenheit. But here it was also discovered that this planet was actually orbiting in a very bizarre way. As in, it's actually orbiting in the opposite direction, in the retrograde way, with a somewhat misaligned orbit, Now this was actually difficult to explain, but might be because of interactions with something else in the star system that we were just not seeing yet. Additionally, this was discovered to be a really old system. This planet is over 10 billion years old, or basically twice as old as planet Earth and planet Jupiter, suggesting that this planet might have been in this orbit for a very long time, but also implying that this planet was a lot more mysterious and way more interesting than we initially assumed, which is why in one of the recent studies, scientists wanted to take a look at this again just to see what's happening in the atmosphere. And the goal was spectroscopy, essentially trying to figure out what other elements we can discover here, which might explain why this planet is so strange, or potentially provide us with explanations to what happens to these ancient planets, especially the ones orbiting in a very strange way. And here they use something known as CRIRES, Cryogenic High-Resolution Infrared Echelle Spectrograph, that basically provides super detailed observations of distant planetary atmospheres, which is really the achievement in this study. It was able to see atmospheric composition of a planet over 500 light years away from us. And so yeah, astronomy has officially entered a completely new era, with the overall technique very similar to what was used before. By looking at the starlight as it passes through the upper atmosphere, it becomes possible to see spectroscopy of various elements, basically determining what's here by comparing it to what we already know from planet Earth and other planetary objects. And here the initial results definitively confirmed water vapor and carbon monoxide inside the atmosphere of the planet. This was obviously on top of previous discoveries from other studies. Here's what these observations looked like. But something here was really bizarre. Instead of just getting one peak, showing us the frequency of specific molecules, scientists observed double peaks for basically every detection, and that by itself was kind of mind-blowing, because here this double peak can only be produced by one phenomenon. This was a Doppler shift. And here is a video showing us how this Doppler shift effect would work, because in this case we have atmosphere that's moving really fast. On one edge it moves really fast toward us, on the opposite edge it moves really fast away from us, and that's exactly what's happening here. This bizarre double edge is basically formed by extremely fast-moving atmosphere that seems to zoom around the planet at 9 km per second, the fastest we've ever seen anywhere, and obviously much faster than anything in the solar system. For example, here on Earth, the highest speed of winds recorded anywhere was from a cyclone in Australia in 1996 with speeds of approximately 110 meters per second. Although technically a tornado can be even faster, reaching speeds of 140 meters per second. Now Jupiter and Saturn are pretty fast, but it's actually Neptune that holds the record for the fastest wind ever measured, 500 meters per second or 1800 kilometers per hour, which is almost 20 times slower than what's happening on this planet. So this is definitely something we've never seen before, and it's definitely the fastest wind we've ever measured anywhere. Okay, not like on a star, because some stars do move pretty fast, but in terms of planetary winds, this is definitely a record. And what's even stranger is that in this case, the wind seems to move at least 6 times faster than the actual planet. So basically, even though the planet spins around its axis pretty fast as well, the winds go around the planet 6 times as fast. Now obviously here it's not clear if this is actually what makes this planet poofy. In other words, maybe this planet is so expanded and so inflated because the winds are moving so fast that they basically escape the planet and move around it at very high velocities. But what is clear is that this planet is definitely bizarre. Although intriguingly, because of the incredible instrument that was used for this study, scientists in this case were also able to measure temperatures, specifically differences in temperature in various planetary locations. And here they were able to determine that there's a definitive difference between the morning and evening sides, which I mean is kind of obvious, but here just being able to measure this is already pretty impressive, but also confirming that the poles on this planet seem to be much colder than the rest of the planet as well. So essentially these observations from over 500 light years away from us even allowed us to measure individual differences on the planetary surface when it comes to temperature. And by itself this is an incredible study. We essentially have our first detailed investigation of very complex atmospheric differences and even temperature differences, and a confirmation that an exoplanet somewhere out there has very similar weather patterns to planet Earth and planets like Jupiter. But because this is just a first such study, we still don't really have more detail and obviously don't have any explanations. In the future, researchers are hoping to study heat distribution and chemical processes, which will hopefully help us explain how this planet formed, how it ended up with such a strange orbit, and how it ended up so close to the parent star. And all of this will actually become a reality once this telescope, extremely large telescope, becomes operational in Chile in the next few years. It's actually still under construction, as you see from this webcam footage, but by having this telescope, it will definitely be able to observe a lot more, helping us reveal weather patterns on a lot of different planets, even the ones we've always wanted to study, specifically various rocky planets like the ones in the TRAPPIST-1 system, the system you can actually learn about in one of the recent videos in the description, although officially it's not going to begin its operation until mid-2027, and so some of these mysteries will most likely become unresolved for at least a few more years. But when it comes to this particular planet, right now this is just a really exciting and a very unusual discovery. A discovery of an object with extreme atmospheric conditions we've never seen or even imagined could exist. But because there is now a new technique to study these planets, chances are that in the next year or so there will be a lot more similar discoveries and potentially a solution to these spoofy planets and a lot of other extreme gas giants. Hello wonderful person, this is Anton, and in this video we're going to discuss one of the recent discoveries of what seems to be one of the most exciting, potentially habitable exoplanets discovered in the last few years. And exciting really because it seems to be super close to us, and because it seems to orbit a very similar star to our Sun. And so let's discuss the details of this recent discovery, but here I guess let's start with some of the basics when it comes to exoplanets, and especially the ones that we believe might be habitable or potentially contain liquid water on the surface. And so as of 2025, over 7,400 different exoplanets have officially been confirmed, with the link in the description basically showing us each one of them, with thousands and thousands more awaiting confirmation through analysis by various telescopes. And though billions of exoplanets are expected to exist in the entire Milky Way galaxy, what's really surprising is that in the last few decades, since some of these first discoveries, scientists realized that the majority of exoplanets out there seem to be unlike anything in the solar system. The vast majority seem to be either super-Earths or mini-Neptunes, quite a lot of them seem to be Jupiter-like, and very often orbit extremely close to the star, and only a very small portion of exoplanets has been discovered to be terrestrial or some kind of a super-Earth. And of all of these thousands and thousands of discoveries, only a very small number of exoplanets has been found to be in locations where we basically expect liquid water to exist and where we hope some of these exoplanets might host habitable conditions. Now this is mostly based on estimates of habitability by the Habitable World Catalog, a database you can find in the description below, combined with the data from the NASA Exoplanetary Archive that should be also in the description. And in this catalog, out of nearly 10,000 exoplanets, only 70 have been discovered to be potentially habitable, and only 29 seem to be rocky, with a chance of having surface liquid water. The other discoveries seem to be either mini-Neptunes or a variation on some kind of a gas planet, such as the previously discovered and previously discussed Hycean worlds and steam worlds. But even here this list is extremely optimistic. The majority of all planets in this list are actually extremely different from planet Earth and from anything in the solar system as well. But it is based on a relatively simple assumption. The assumption that surface habitability requires a certain distance from the star in order to potentially host liquid water, but also requires specific geophysical and geodynamical properties, including specific atmospheric density, specific type of star with very specific radiation, and even the plasma environment in the entire star system. For the majority of these planets behind me, most of these properties are actually unknown, and so even here, chances for these planets to be actually habitable and potentially contain liquid water is still extremely low. And so this whole list becomes much smaller if we make more conservative assumptions, ignoring star systems where we actually don't know certain properties. For example, ignoring some of the larger planets. It's extremely unlikely that a larger planet is going to be rocky, and if it's not rocky, it's unlikely to have oceans similar to planet Earth. So here everything has to be under 10 Earth masses and smaller than 2.5 Earth radii. On top of this, we probably don't want to study planets around stars that are too active or too extreme, such as the famous red dwarfs. And the thing is, if you look at this list, the majority of planets discovered are basically around M-type stars, red dwarfs. The most exciting discovery is around TRAPPIST-1 system, and that system seems to be pretty active as well. And so red dwarf stars, or M-type stars,
are maybe not the best examples either. Mostly because these star systems are very different from the solar system, and the planets in these star systems are going to be very different as well. For one, they're all going to be tidally locked, always facing with the same side to the star, but also receiving huge amounts of X-ray radiation and huge amounts of flares coming from the star, mostly because they're so much closer to the star compared to planet Earth. And so in that sense, some of the most exciting exoplanets astronomers want to study are usually around G-type stars. Stars very similar to our Sun, except that G-type stars are not very common. They seem to only represent approximately 7% of all stars in the stellar neighborhood, and not a lot of planets have been discovered around G-type stars compared to anything else. For example, our neighbors, Alpha Centauri, is a system of a red dwarf, a K-type star, and a G-type star. And we know that the G-type star does not seem to contain any planets around it. With a partner that's a K-type star, a little bit smaller and less massive, doesn't seem to contain anything either. Now the third partner, Proxima Centauri, does contain a planet, but it's a red dwarf. And so despite having these really exciting sun-like stars around us, so far nothing has been discovered in the habitable zone around them, with similar discoveries around other G-type stars as well. And that's basically because it's just hard to find exoplanets in general, but especially around certain types of stars. And so if we go through this list again, and cross out anything that seems to be around some kind of a super active star or a star different from our Sun, we're actually left with just a handful, and a handful that we know very little about. Now we've actually discussed many of these exoplanets in some of the previous videos that should be in the description, but here we have Kepler 1606b at 2700 light-years away from us, a potentially rocky planet in the habitable zone of a G-type star, although in this case, since it's so far away from us, it's super difficult to study anything about this planet. We also have Kepler 452b at 1800 light-years away, once again potentially rocky, but same problem as before, just way too far to discover anything else. And we have Kepler 22b at 635 light-years. So basically just 3 exoplanets around G-type stars in potentially habitable zones. Now technically there's actually one planet around a K-type star that's also potentially exciting, but we don't know enough about K-type stars to know if they're similar to G-type stars like our Sun. In contrast, all of the nearest potentially habitable planets discovered in the last decade all seem to orbit red dwarfs, and in many cases very active red dwarfs. You can find out more about some of these planets in additional videos in the description below. But then, if you keep going down the list, there is actually one intriguing object, and it's an object you see right here, sometimes referred to as A2G Eridani D, but also referred to as HD 20794. And while this is one of the closest G-type stars to us, and for many years scientists speculated that it potentially has a bunch of exoplanets as well, but it was just very difficult to discover what sort of planets and at what distance from the star. Now even today it's not actually clear how many planets there are, but possibly 4, although only 3 have been officially confirmed. And this, as you can see, is only 20 light-years away from us, and is also a relatively mild G-type star, a little bit less bright and a little bit less massive than the Sun, with 80% of solar mass and 90% of solar radius. But it's also just a little bit older, possibly 5.8 billion years old, so just over 1 billion years older than the Sun. And so after 2 decades of observations, we actually have enough data to finally confirm certain objects here, and specifically one really exciting planet. First of all, the star system here seems to contain some kind of a dust disk at approximately the same distance as Uranus from the Sun. It's not entirely clear why this disk is there, but it's maybe something similar to the asteroid belt in the solar system. Likewise, we can now confirm 2 of the closer planets to the star, both a little bit more massive than planet Earth, and one orbiting every 18 days, one orbiting every 90 days, with both of these planets basically being super-Earths and very likely extremely hot. But a recent detailed observation of the third planet, planet HD 20794d, revealed that this planet seems to be actually orbiting right in the middle of the habitable zone disk. Except that this one is also potentially a super-Earth, and very likely the biggest planet in that star system as well. It's about 5.8 masses of planet Earth, and is very likely either some kind of a very large terrestrial world, or possibly some kind of a mini Neptune. But in this case, it's hard to know for sure because we've never really seen a transit of this planet, so we don't really know its exact size. As a matter of fact, this planet was discovered by measuring what's known as radial velocity, observing the motion of the wobble of the star
by looking at the miniature redshift and blueshift anomalies. That's how the scientists know its exact mass and how they're able to work out the exact orbit. And so in this study, by using some of the most advanced instruments such as espresso and HARPS, able to study exoplanets with extreme detail, and also using 20 years of observations from various other telescopes, scientists definitively confirmed the existence of this somewhat strange planet. Strange because of its orbit. It does not have a circular orbit, and it seems to be quite eccentric. It seems to extend from about 0.7 AU at its closest, which is around the same distance as Venus from the Sun, but then go all the way to 1.5 AU, which is basically where Mars is located away from the Sun. And so every 650 days, this planet goes between these two extremes, with a single year actually being relatively similar to what we have on Mars, or approximately 40 days shorter, with this very elliptical orbit suggesting extreme changes on the surface and potentially extreme climatic conditions that basically change throughout the year. But because in this case, this star is actually not as hot as the Sun, there is now a very high chance that, assuming that this is a terrestrial world, and assuming that it has any water on the surface, that water could potentially become oceans. Because even at its closest to the star, it's still not going to receive as much heat as Venus. But more importantly, because the star system is so close to us, and because this is such an exciting world, and also because the star is quite luminous and relatively stable, it presents us with an excellent opportunity to observe the atmosphere of this planet at some point in the future, essentially allowing us to figure out what sort of a world this is, figure out if this is a habitable world and if these planets can be habitable, and even figure out what happens to planets with such extreme orbits. Now, we obviously have no idea how it assumed this orbit, but very likely because of the interaction with something else in the star system that changed its orbit so much. And so if this planet is terrestrial, it might resemble something like this. And also, if it does have water on the surface, this water would basically go from the ice state to water state pretty much every single year, which is technically not a bad thing. We know that these dramatic changes are maybe one of the main reasons Earth, early on, was able to develop life on the surface, as a lot of early conditions were actually quite extreme, especially because of the interactions with the Moon. And so the orbit of this planet technically also makes it somewhat exciting. And so even though technically this is the 12th closest habitable exoplanet to planet Earth, in reality, because this is the only one around a G-type star, it seems to be the most exciting and the most interesting of them all. The only planet we've found so far that has such a unique orbit, and the only one around a star very similar to our Sun in basically solar neighborhood. Hello InfoPerson, this is Anton, and today we're going to discuss a discovery of what seems to be the most volcanically active exoplanet we've seen anywhere. An unusual terrestrial exoplanet that was actually discovered a few years back, but that has now been observed with the James Webb Space Telescope, which was able to detect volcanic emissions from around the planet, while also discovering something else somewhat unusual about the planet, and so it's actually worth discussing today. And so let's talk about this planet in a system of L9859 and discuss why this is actually kind of exciting. But I guess first of all, so technically this is not the first time different types of volcanic activity has been detected outside of planet Earth. Now obviously the most famous volcanic object is Jupiter's moon Io, that by the way we actually recently discussed because it was able to produce some of the most spectacular volcanic eruptions in the entire solar system. But when it comes to looking at exoplanets, due to distances, this becomes a little bit more complicated, because here we cannot observe these eruptions visually, but we can observe emissions of gas around these planets by studying the starlight as it passes through some of these molecules. But I guess the question is, why? Why even bother with these volcanic planets? Well, it's mostly in regards to what's known as red dwarfs, or M-type stars, which basically represent the most common types of stars in the entire galaxy. But on top of being common, red dwarfs also possess the most amount of terrestrial planets we've ever seen anywhere. For example, the famous TRAPPIST-1 system contains 7 terrestrial planets, and at least 3 of them seem to be in the habitable zone of the star. But a lot of these stars are also extremely active and tend to produce a lot of flares. And so quite a lot of previous studies determined that it might be impossible for many of these planets to maintain atmospheres. Like, at all. All of them might be completely barren, and thus have no chance for liquid water and obviously life. As a matter of fact, 2 of the 7 planets in the TRAPPIST-1 system have already been discovered to potentially have nothing. And so trying to assess the prevalence of atmospheres around M-type stars or red dwarfs is actually one of the biggest priorities in a lot of different exoplanetary research.
Or just to rephrase this, can rocky planets around red dwarfs actually have atmospheres? And well, additionally, some other studies actually propose that there might be a way, and that way is through, as you probably guessed, volcanism. Even though a star might strip initial atmosphere, if a certain planet has a lot of volcanism on its surface, this might actually provide it with just enough resources to continuously replenish its atmosphere. In other words, this is maybe one way for many of these planets to have permanent atmospheres, even though these planets might not be super hospitable. And it just so happens that back in 2021, one such planet was proposed to be the perfect candidate to study all of this. This is a system known as L9859, and here several planets have already been confirmed, as you can see from this NASA simulation. But specifically the closest planet, Planet B, seems to actually be smaller than planet Earth, and is even less massive at approximately half the mass of Venus. And this is also not very far, approximately 35 light years away from us. So this is almost definitively a terrestrial planet. Moreover, this is a multiplanetary system with 3 confirmed and 2 unconfirmed planets, with actually one of them in the habitable zone. But it's really the smallest planet that seems to be of the most interest. And back in 2021, this was officially one of the smallest planets ever discovered, until the discovery of something even smaller we've discussed in one of the previous videos. And it was also one of the lowest in mass planets as well. Not the least massive, but definitely in top 3. And here the planet was orbiting very close to the star. It took approximately 2.2 days per orbit, so it was actually very easy to observe. But obviously this also made the planet pretty hot. Here it was receiving approximately 20 times more energy than planet Earth, and was thus estimated to be at least 330 degrees Celsius, 620 Fahrenheit. But then approximately a year after its discovery, in 2022, the initial atmospheric studies unfortunately discovered nothing, as in there were basically no emissions or nothing that was easily visible. But this was before the James Webb. In this case, it was from this study where the scientists used Hubble Space Telescope. But it did not mean that it had no atmosphere. As a matter of fact, there were 2 possible solutions. One is that it was barren, but the other solution was that it could have had an extremely hazy, almost opaque atmosphere, kind of similar to Venus, basically containing a lot of haze in the high altitudes, which blocked most of the light. And because previous studies predicted volcanism here, and even predicted potential atmospheres, scientists wanted to look at this planet again using the James Webb, mostly because it's able to see so much more. Which is why we get this study, the study by Aaron Bello-Aruf and his team. And here the study was very simple, basically observing several transits, and then trying to see if the spectrum coming from the star changed as a result of certain molecules blocking the starlight. And well, here, unlike the Hubble, something was indeed discovered. Here, the transmission spectroscopy, because it was so much more accurate than the Hubble Space Telescope, revealed an almost definitive presence of sulfur dioxide. That's, by the way, what we usually see around Io as well. But here, the amount detected was actually really huge. Because the evidence suggested a lot of sulfur dioxide, it implied volcanic activity at least 8 times more active than Jupiter's Io. So this planet might actually really look sort of like this. And the reason they believe this is from volcanism and not from something else is really because when trying to calculate how likely is this planet to maintain its atmosphere, the chance for that is pretty low. Because in this case the planet orbits so close to a red dwarf, just like with Mercury, it would extremely likely strip everything from the surface, only leaving trace amounts of materials around the planet. But in this case, due to the amount of sulfur dioxide, it suggested that something was probably replenishing it actively. Because if it was not being replenished, it should disappear within approximately 10 million years. In this case though, this is a much older star system, so the fact that we're seeing sulfur dioxide implies activity on the surface. And so in essence, just like predicted, this indeed seems to be the most volcanic planet we've detected so far, and indeed seems to suggest that it's possible for planets to actively replenish their own atmospheres through volcanic processes. Although here we're just talking about planets orbiting red dwarfs. And one of the reasons this seems to be possible is really because of its orbit. Here, because this planet has a relatively circular orbit, and because it has so many neighbors, it very likely experiences a lot of tidal heating, which is really the same mechanism that causes Io to be volcanic as well. And so because of the tidal heating, or because of these gravitational forces acting on the planet's mantle, and basically causing it to move back and forth, it then causes huge amount of volcanism, which is unlikely to stop anytime soon. And interestingly, something very similar was actually discovered around a different planet, the one you can learn about in one of the previous videos in the description, the planet LP79118, that was also very similar in size to this planet, and based on gravitational interactions, and thus assumed to be potentially volcanic too. And so this tidal interaction might be one of the ways for many of these planets to continuously replenish their own atmospheres, thus maybe even creating somewhat hospitable conditions for some kind of life. And though it's obviously still possible that maybe this signal came from something else, and maybe this planet is actually still barren, as originally observed by the Hubble Space Telescope, obviously until future observations we're not going to know for sure. Nevertheless, right now this does seem to be the most volcanically active planet ever seen, which would basically suggest an enormous subsurface magma ocean, very likely representing at least 60 to maybe even 90% of the entire volume, responsible for all of these volcanoes. But more importantly, the study also calculates that it's quite possible for this planet to continuously replenish a lot of different gases and not just sulfur dioxide. As a matter of fact, depending on the composition, this planet could easily contain a relatively hospitable atmosphere, although obviously in this case it would be maybe just a little bit too hot. But a similar planet at a slightly farther away distance that still has volcanism on its surface does actually have a pretty high chance to maybe even be habitable long term. And so when it comes to exoplanetary discoveries, this one is actually pretty important. Hello wonderful person, this is Anton, and today we're going to discuss a relatively new discovery coming from, I guess you would call it, cosmic neighborhood. A discovery of yet another terrestrial planet, but this time super close to us. A planet around a very famous star known as the Barnard star that's technically one of the closest objects to the solar system. And so let's talk about this in a little bit more detail. But here first, let's talk about why this is actually a super exciting discovery for a lot of astronomers out there. And that's despite the fact that thousands of planets have already been confirmed, and a lot more exciting planets have been discovered in a lot of other star systems. And so here, let's start with a bit of a history. And I guess let's start with the name first. Why Barnard star? Well, it's named after this guy, Edward Emerson Barnard. Barnard? I don't know, it's one of those names I've only read, never heard pronounced by anyone, so I'm going to assume Barnard. An American astronomer who back in 1916, or essentially 108 years ago, discovered an unusual star moving really fast in the night skies. Or at least fast compared to other stars. It basically had a relatively high proper motion, moving laterally at 90 kilometers per second. And because he was the first to discover this, and because this was actually before any star naming convention existed, this somewhat dim red dwarf eventually became known as the Barnard star. And because this guy was pretty prolific in discovering other things, he actually has a bunch of other objects named after him, even a galaxy. But one of the main reasons why this star was actually kind of exciting for a very long time is really because of its distance to us. This is, as I mentioned, one of the closest objects to us. Now Proxima Centauri is a little bit closer, Alpha Centauri as well, but then we have the Barnard star. Currently, it's only about 5.96 light years away from us, and it's essentially one of the closest objects ever discovered. Intriguingly, it was even discovered before Proxima Centauri. But both Proxima Centauri and Barnard star represent the closest red dwarfs to us. And as you might already know from some of the older videos, one of which is in the description, a while back, two separate planets have been officially confirmed around Proxima Centauri. One of these planets is extremely similar to Earth in terms of size and mass, and is also in the habitable zone. And so because of that discovery of Proxima b, and because of previous studies suggesting that many red dwarfs should have planets in habitable zones, the next obvious target has always been Barnard star, more officially known as Proxima Ophiuchi, which led to an extensive search in the last few decades. And there was actually one important reason why Barnard star was a little bit more exciting than Proxima Centauri. Proxima Centauri is what's known as a flare star. It's basically a red dwarf that's still kind of active and tends to produce massive flares, emitting a lot of X-ray and ultraviolet radiation that within just a few million years can actually strip any atmosphere and destroy any liquid water on pretty much any planet. And it just so happens that many red dwarfs turn out to be this. They're just a little bit too active for any life to survive on the surface. But when studying Barnard star, researchers discovered that it seems to spin really slow, and thus its age is much higher. In other words, Barnard star was potentially much calmer, and because its age was established to be 7 to 12 billion years, and because it was one of the older red dwarfs out there, it was assumed to be calm enough to potentially have hospitable conditions for terrestrial planets. but there were two problems. First problem was that initially no planets have been discovered here, and a second problem came in 1998. Despite being an ancient star, it experienced a massive stellar flare detected in 1998. And once this flare was discovered, the star officially became a flare star as well. With all this confirmed in 2019, when two additional ultraviolet flares were detected as well, with a total energy released being much higher than anything our Sun produces during a typical very active stage. And so by observing these flares, researchers eventually calculated that a typical planet orbiting around the star would probably lose one Earth atmosphere every 10 million years, which obviously suggested that this was not a star for habitable planets. But still, researchers wanted to find something, anything. Basically, where are all the planets? And the thing is, since the early 1960s, there have been a lot of arguments for the existence of planets in the system, specifically gas giants. And so actually, as early as 1970s, several astronomers, including Peter van de Kamp, argued for the existence of some kind of a gas giant that was potentially detected using initial observations. But here this was detected by using extremely early and very inaccurate techniques using what's known as astrometry, or basically observing tiny deviations in motions of a star as it travels across the night skies. But back in the 60s and the 70s, astrometry was at its infancy and was basically very inaccurate. And so it didn't take long to basically disprove this idea, eventually proving that there was no gas giant here at all, and the star was not wobbling as much as initially assumed. Here's actually a really cool image showing us how the star compares in terms of size to Jupiter and to our Sun. But then, in November of 2018, a new study using new techniques revealed a potential super-Earth, or basically a planet a little bit more massive and a little bit larger than planet Earth, orbiting at 0.4 AU away from the star. And here this was detected by using a different technique known as radial velocity, essentially by observing the wobble of the star, but this time through the observations of the redshift and the blueshift coming from the starlight itself. But turns out that these observations were maybe not precise either, because by 2021, or approximately 3 years later, this signal was discovered to be not coming from the planet, but very likely from the stellar activity and just from the star itself changing in color by just a little bit. So basically it seemed to be some kind of a variable star effect and not really a planet at all. This is not the first time such a discovery has been made, and not the first time variability of a star fooled us into thinking it was a planet, with additional studies in 2022 confirming that this was not a planet after all. And so basically, in the last 5 decades, lots and lots of papers came out trying to find something here and discovered absolutely nothing. And this was super unusual because, as I mentioned previously, modern theories predict at least a few terrestrial planets around most red dwarfs. So what's exactly happening here? And interestingly, in the last decade or so, a lot of detailed observations revealed that there was possibly nothing here as far away from the star as a 1,000-day orbit. At least nothing comparable to planet Earth or larger in mass. And there was definitely nothing in the habitable zone that could have been similar to planet Earth, like in the Proxima Centauri system. And then, a few hours ago, from when I'm making this video, I got an email saying, "Attention, embargo, don't talk about this until, today basically." And that's because something finally has been discovered here, but we were not supposed to talk about it until now. And so let's talk about this new discovery that seems to be super official and definitely there, because in this case, the actual evidence seems to be very strong. Now, usually when I get these embargo emails from the European Southern Observatory, it's because something big has been discovered, and they just want all of the press to talk about this at the same time. And normally you can actually get these emails yourself if you subscribe to their newsletter. But this time it was really the study itself and the amount of data included in the study that was kind of exciting. Now, as always, you can find the study in the description below, but here the title says it all. A sub-Earth mass planet orbiting Barnard star, discovered using ESO's extremely accurate and very precise Espresso instrument and HARPS instruments in the La Silla Observatory. And one thing these instruments do really well is basically this. They can do radial velocity with absolutely unprecedented accuracy. In other words, they show us how something wobbles around something else by observing redshifts and blueshifts, but this time with accuracy we never had before. And these instruments are relatively new, they've only been operational for a few years, but we know their accuracy is very high. And well, this time the focus was Barnard star, because here astronomers just really wanted to find something, anything. I mean, like, please, because it just doesn't make sense that there would be nothing here. And well, eureka, there was something after all. And the reason it was invisible before was because it was just not massive enough. It is a terrestrial planet, but as the title suggests, it's a sub-Earth planet. And so here, by looking at signals from the habitable and the temperate zone of the Barnard star, they discovered and then confirmed a planet very, very close to the star. A planet that orbits every 3.15 days and very likely has a temperature of about 125 Celsius. So definitely hot and definitely too close for any habitable conditions, but still super exciting. And actually exciting for maybe one more reason. This seems to be one of the lowest mass terrestrial planets ever discovered, with a mass equivalent to approximately half the Venus, and specifically approximately 0.37 masses of planet Earth, which is surprisingly 3 times the mass of Mars. And it seems to have a perfectly circular orbit, visible in the way the star wobbles. But obviously, because it's so close to the star, it's unlikely to have any atmosphere and unlikely to have habitable conditions. But still, we finally found one planet here, and it's, as predicted, a terrestrial planet. But what's even more interesting, this new data suggests that there might be actually 3 more planets hiding somewhere in the vicinity, specifically orbiting slightly farther away, with maybe a period of 4 days, 2.3 days, and 6.7 days, with additional planets potentially being even smaller. And so in other words, one of the explanations for why no planets have been discovered previously is because they seem to be kind of tiny, much smaller than Venus, a little bit bigger than Mars, and basically Mars and Mercury-like in appearance and potentially surface conditions. And so along with the discovery of Proxima b and Proxima d, this once again confirms that there seem to be a lot of terrestrial planets near us, and quite a few of them are very similar to what we have in the solar system. Although in this case, in this particular study, they once again also confirmed that there seem to be no gas giants and no additional super-Earths as initially reported in previous studies from 2018 and from 1970s. And because here the observations were ultra accurate, it's extremely unlikely that this is a mistake. But I guess only time will tell what else we discover in this system, and more importantly, what sort of planets these are, what's on their surface, and if any of them contain conditions necessary for life to survive. Hello wonderful person, this is Anton, and today we're going to discuss a somewhat unusual discovery coming from approximately 12,000 light years away from us. A discovery of what seems to be a star officially confirmed to have swallowed one of its planets, but in a somewhat bizarre and unexpected way. And specifically confirming that planets being eaten by stars is definitely something that's really common, but also providing a very important resolution. A resolution in regards to some of the most common types of planets we've discovered so far that don't seem to exist in the solar system. And so let's talk about this recent study and the observations from the James Webb. But first, let's start with a study from approximately 5 years back. And here it was in regards to this. ZTF SLRN 2020, an unusual and somewhat bright emission, suddenly detected 12,000 light years away from us in the year 2020, as the name implies. This was part of ZTF, or the Zwicky Transient Facility, which is a kind of an automated system named after the Swiss astronomer Fritz Zwicky that observes visible and the infrared wavelengths in order to detect transients or sudden bursts of light somewhere out there in the universe. And this actually can be caused by a lot of things, obviously nova and supernova, but also even things like comets and asteroids suddenly erupting as they approach the sun. And while in 2020 it discovered a very bizarre subluminous red nova that at first did not make much sense. You can actually see the before and after picture right here. And this outburst lasted for at least 6 months. But it was not bright enough to be a nova or a supernova, so it had to be something else. There were also no X-ray or gamma ray emissions, so whatever this was, it was probably caused by an entirely different phenomenon. And while eventually additional observations revealed that this is most likely a star swallowing a planet. And essentially it was proposed to be this. This star, that was probably somewhat similar to our Sun, became a red giant and have become so large that it basically swallowed one of its gas giant planets, with all of this lasting for approximately 6 months. And this conclusion was reached after analyzing pretty much every wavelength and discovering that there were indeed signs of planetary leftovers, with the overall change of brightness predicted by various models as well. And surprisingly, this was potentially the third time such an unusual event was witnessed. But this one provided the most data and was practically seen in real time. And so here, back in 2020, scientists believed that they found evidence for a star in its final stages of life, engulfing a planet just as predicted by various models. But now, after 5 years and additional observations with the James Webb, the story seems to have changed a little bit. Because here, additional infrared observations revealed something a bit more unusual. Now, first of all, because this was such an unusual event, scientists really wanted to take a look at it with the James Webb just because this was so bizarre. And they actually did receive guaranteed time on the telescope, specifically with a program that's meant to observe different anomalies. And so some of the first infrared observations were made approximately 830 days after the optical emissions and the swallowing of the planet. And almost right away, researchers realized that there was actually a bit of a mistake initially. Turns out this was not a red giant at all. As reported in this study by Ryan Lau and his team, in mid-infrared and near-infrared observations, this star was actually your typical K-type star, also known as the orange dwarf, which basically implied that this star can technically survive for up to 70 billion years, and it was definitely not anywhere close to becoming a red giant. Now, a star like our Sun is expected to become a red giant after maybe 9 to 10 billion years. But this type of a star, that's about 70% the mass of the Sun, can easily survive up to 10 times longer. And so since the star discovered here was much smaller, more dim, and even much cooler, it was definitively shown to be a main sequence star, not even close to being a red giant. And actually this star seemed to be pretty young, full of energy, with billions and billions of years of hydrogen left to burn. Which of course meant that this type of a scenario was completely out of the question. But the signs of a planet being swallowed were still there. As a matter of fact, planetary collision, or planetary engulfment, was still the best explanation. So obviously the next question was, alright, so what actually happened then? And well, the best explanation is of course the alternative type of a collision. The collision when the planet gets super close to the star, and essentially because of the interaction with the outer shell of the star, starts to slowly lose its orbit, eventually coming closer and closer to the star, and then in a very short period of time evaporates, with the rest of the planet absorbed by the star itself. And in the past we've actually discussed quite a few planets, specifically the so-called hot Jupiters, that essentially orbit the star so close that they're practically touching the edge already. In many cases these planets produce really large tails, as a lot of their atmosphere evaporates. But naturally we've never seen the end product, or the actual process of the star eating the planet and finally absorbing it into itself. And that's despite the fact that hot Jupiters technically represent some of the most common planets discovered so far. And so far, scientists have also seen pretty much every major stage. Even the stage involving these massive tails, we discussed one of these not so long ago, when a humongous tail of helium was discovered in a star system nearby, and a lot of other objects evaporating as they orbit the star. But there was always a question of, okay, so what happens after though? Does the planet just evaporate, potentially becoming some kind of a rocky core? Does it evaporate completely, leaving nothing behind? Or does something collide with the star as well? And it looks like we finally have that answer. Because right now the best explanation is that this hot Jupiter slowly evaporated, losing its orbit over time, with the orbit decaying even more over several million years. And this was basically the result of the planet smacking into the outer layers of the star, which would reduce its velocity over time, dropping its orbit. And so after millions of years of the interaction with the star's atmosphere, it eventually left a mark on the surface of the star, leaving behind a lot of gas around the star, but then finally collided with the star, disappearing inside of it, causing the star to poof up just a little bit and increase in brightness. Something that potentially lasted for approximately 6 months, which is what we basically see right here, with the additional observations using near-infrared frequencies, additionally revealing several types of gas clouds and even certain molecules that were sort of unexpected. For example, first there was the presence of a relatively warm circumstellar dust that seemed to be about 720 Kelvin and was forming a kind of a ring around the star, but also the presence of what seemed to be a kind of a puffed up cloud around the star with a much colder and much more massive dust that was about 300 Kelvin in temperature. So basically here we had both the accretion disk from the final collision and a kind of a puffed up ejecta, possibly the result of some kind of a final event that released all of this gas around the star, with the overall process described in this image. So basically here we have a kind of an inspiraling planet, most likely a gas giant, that eventually got absorbed by the star. But intriguingly, this hot molecular gas around the star seemed to contain things like carbon monoxide and phosphine. And this carbon monoxide seemed to actually resemble something we usually find around extremely young stars and protoplanetary disks, which potentially suggests that all of this gas might now start forming something else once it cools down. But the colder gas that seems to be present around the star, that's actually very likely coming from the star itself. And that's because as the planet interacted with the outer shell of the star, a lot of this gas started to escape the star, expanded, cooled off, and eventually formed this much colder gas, still present even after 5 years. Although it's quite likely that this is just an ejecta that's going to return back into the star with time, possibly changing some of its spectra once again. But right now, only future observations will tell us what's going to happen to the star in the future. For example, one big question here would be, what's going to happen to this ring? Is it actually going to coalesce into something else, like for example, a smaller object? Or will it also disperse over time, returning back into the star, or possibly get blasted away into the outer star system? Either way, this is still a super exciting discovery, and essentially makes this the first ever confirmed planetary engulfment that was seen in real time. Engulfment not related to the star's age, and the engulfment that shows us what happens to hot Jupiters right at the end. With the next really big question to answer being, okay, so did this ever happen in the solar system? And if so, how can we actually find out? Because one big mystery about the solar system is that we don't really have hot Jupiters or mini Neptunes. And the question is, why not? These are extremely common exoplanets, and they've been discovered around most star systems out there. And so it's quite possible that back in the days, billions of years ago, maybe something very similar happened to our Sun. And if so, what exactly happened to the ring? Today I wanted to discuss one of the strangest exoplanets discovered in the last few years. Actually, in this case, not just the exoplanet, but in some sense the entire star system. The system that you see right here, known as WD 1856 plus 534. A system that potentially created a planet entirely out of leftovers from some kind of a destroyed or potentially swallowed star. And a planet that now seems to be located in the habitable zone of the star system. And so here there's actually quite a lot to unpack. And so I guess let's start with the basics. Hello info person, this is Anton. Let's talk about the discovery of this unusual white dwarf, the planet orbiting around it in the habitable zone, and how this bizarre system was potentially created. And technically this planet was discovered back in 2020. I think there might be even an older video about this, that should be somewhere in the description, mostly because the planet in this case was so strange. Here we clearly had an unusual white dwarf in a triple star system that actually contained a couple of red dwarf stars as well, but the white dwarf that was a little bit colder. Based on the spectrum you see right here, it was about 4400 Celsius, 8000 Fahrenheit. And that suggested that this white dwarf was pretty old, maybe about 5.8 billion years old in total. It was also approximately half as massive as our Sun, but was either the same size or maybe just a little bit larger than planet Earth in terms of radius. And just like a lot of other unusual white dwarfs, usually the ones involving some kind of a disk or unusual elements on the surface, in case of this white dwarf, it appeared to have something in its orbit at a relatively close distance. It was about 0.02 astronomical units away from the center, roughly in the orbit you see right here. And that something could only be some kind of a planet. Possibly same size as Jupiter, but very likely not a brown dwarf, with a mass of about 1 to maybe 12 masses of Jupiter in total, and a single orbit of 1.4 days. And so essentially here, every 1.4 days, something was pulling on this white dwarf, suggesting a relatively massive object. But I guess more excitingly was the actual location for this planet. White dwarfs, unlike typical stars, obviously don't produce as much heat, and so their habitable zone is also much closer. And it just so happens that this particular planet was literally right in the middle of it. implying that this planet, if it maybe had some moons or something, those moons could be habitable as well, making this planet super exciting for a lot of scientists. But it was still a gas giant, and there were obviously no signs of moons whatsoever. As a matter of fact, the initial observations of what this planet might look like potentially even suggested some kind of a featureless gray world, very likely entirely covered in hazes. And so basically this was just a strange planet. And so many different scientists wanted to figure out where exactly did it come from. Mostly because a typical planet should not form so close to a white dwarf, even if this white dwarf had a really large disk around it. As a matter of fact, any planet in this location should have been already shredded apart a long time ago. Yet it was clearly not destroyed, and it was clearly here. And so the first suggestion from back in 2020 was some kind of a planetary migration. This was possibly a planet much farther away and eventually made its way closer and closer, possibly because of the gravitational pull from the nearby red dwarfs. This is a triple star system, and so the white dwarf here has at least 2 partners. But a much more interesting explanation, and possibly a more likely explanation, was just explained in a recent study you can find in a description. And here the assumption is really simple. We know that the majority of systems out there seem to be binary, just like the binary partners of this particular star. And we know that many white dwarfs do actually form in binary systems, where sometimes there's another larger star in their orbit. And so here there's actually a possibility that back in the days, over 6 billion years ago, this was just 2 regular stars, one possibly similar to the Sun, and one maybe a little bit smaller, some kind of a red dwarf once again. And eventually, just like so many other stars, that Sun-like star started to become a red giant and basically enveloped its partner. It actually formed a really cool phenomenon referred to as common envelope. And so here the smaller red dwarf literally entered the larger star and started to orbit inside of it, inside that common envelope. And we actually know these stars exist and do produce very specific observations, but in many cases they also produce some really extreme binaries, such as sometimes neutron stars, black holes, and so on. And so in essence what we have here is a core of a larger star, which is going to become a white dwarf, orbiting a smaller red dwarf, literally inside of itself. And modern explanations propose one of 2 potential resolutions. Either a merger that results in a nova-like explosion, such as the famous V838 monocerotis you see right here. The videos in the description talk about this a little bit more. Or the envelope disappears and dissipates, and we actually end up with some kind of an unusual binary. Very often some kind of a neutron star and some kind of a smaller star, or possibly some other binary object in a very tight orbit. Now these have been actually found pretty much everywhere, but up until this point, we've never actually seen anything like what we're essentially seeing right here. And so in this case, in this star system, several mathematical models were successful in reproducing an extremely similar star system. A system of a really unusual planet orbiting a white dwarf super close. But in this case, a system that involved a potential destruction of a smaller star inside of that common envelope. And so here, the smaller star, once it entered the common envelope, it might have been completely disrupted tidally, which essentially destroyed the star, producing a relatively massive accretion disk somewhere in the center. In other words, here, we essentially have some kind of a third scenario. Instead of a binary system, and instead of a collision, we now have a central core, an accretion disk, and that common envelope. According to that model, this could only happen if the smaller star was just the right size, entering the common envelope of a Sun-like star. Here the smaller star had to be approximately 15% the mass of the Sun. And within just a few orbits, that smaller star would start to be tidally disrupted, basically in some sense being completely destroyed inside the larger object. But destroyed in such a way that it now left behind an accretion disk that was now left behind orbiting the core and that was still inside of that common envelope. But eventually the envelope disappeared, yet the accretion disk was left behind. But it was no longer as massive and contained just enough mass to produce that one Jupiter-like planet, which eventually formed in the orbit that we see right now. And so in that sense what we're seeing is basically a second-generation planet, but in this case also produced entirely out of another star. A star destroyed by tidal disruption, and the star that was inside the common envelope, which basically suggests that this planet was literally produced inside another star. And if correct, this would be really unusual, very peculiar, but would also explain why this particular planet and its spectrum right now seems to be kind of bizarre. As mentioned before, this planet seems to be kind of hazy, does not seem to contain a lot of spectra that are very easily visible, and overall appears to be different from anything else. And I guess more importantly, once again, it is in the official habitable zone around this bizarre white dwarf. Although I guess technically it's a yellow dwarf, because it's actually much colder and does appear yellow from a distance. But more excitingly, because this white dwarf is going to maintain this temperature for a very long time, technically, this planet is going to be in this habitable zone in very constant conditions for possibly several billion years. And so here discovering any kind of a habitable moon, if it is possible, would actually be super exciting. But right now we don't even know much about this planet, as no additional observations have been conducted yet. As a matter of fact, analyzing its spectrum can prove to us that it actually did come from a star formed as a result of a tidal disruption. So measuring elemental composition of this planet and this white dwarf would definitely be the next important step. But obviously this is just a hypothesis, and right now nobody is really certain how this planet was formed, why it seems to be in this unusual location or unusual orbit around this white dwarf, and there are obviously still a lot of unanswered questions about what's going on its surface. But hopefully, in some of the future observations from other telescopes, scientists will get additional data to be able to answer some of this. Right now, it's still a big mystery, but it's definitely looking more and more likely like this is some kind of a never-before-seen event, such as a tidal disruption of a separate star swallowed by its own partner. In one of the most recent press releases, NASA and ESA released a study and a few images in regards to one of the strangest planets out there in terms of orbits. A planet orbiting two stars in the way you see right here, perpendicularly. You can read a little bit more about this in one of the links in the description. And though by itself, this type of an orbit and this discovery are obviously just a little bit unusual, they're not impossible. As a matter of fact, similar circumbinary planets with even similar polar orbits have technically been discussed before, and they can easily be explained using modern physics. But today we're going to discuss a slightly different discovery that actually started as a mystery over 2 decades ago. And that particular planet is extremely difficult to explain, although once again, not the planet itself, just its orbit. Today we're going to discuss a star system known as New Octanis, a system that officially became somewhat intriguing sometimes between the late 90s and some of the first investigations in 2004. But ever since the original observations, there's actually been a bit of a mystery because a lot of things here just did not make sense. As in, if there was a planet, it made no sense how it was able to orbit around a star. And so in this video, let's discuss some of these new discoveries and the most recent paper finally confirming the existence of this bizarre planet, and of course discuss why this should not exist and how this is currently being explained. But first, a little bit more about the star and what researchers detected here many years ago. And this was a study by David Ram, an optometrist who back in 2004 finally completed his PhD in astronomy. And so basically, just like so many of us, he switched his career after many years. And almost right away he discovered a very bizarre mystery around the star, a very subtle form of some kind of a stellar variability that potentially suggested a planet. But the thing is, this was already known to be a close binary. And so here we have two separate stars, a brighter K-type star approximately 1.6 masses of the Sun, but about 5 times as large, orbiting around a much smaller star that seems to be a white dwarf, 0.6 masses of the Sun, and orbiting at a distance of about 2.6 astronomical units. And so here a single orbit takes almost 3 years, which by itself is obviously not unusual. But as researchers observed this star more and more, they started to detect somewhat subtle variability, as if something else was in orbit, basically right between these two stars. But in this case, orbiting one of the stars, but much farther away than expected. And here this was discovered by using the method known as radial velocity, essentially observing the redshift and blueshift and trying to find various periodicities suggesting something is in orbit. But because this was so subtle, and because this was using much older telescopes, and also because this orbit would be very unusual, as in it would be unstable, simply because it's right between these two stars, one of the first propositions for this bizarre Doppler effect was basically some kind of a stellar activity. Or maybe these periodic variations were just a result of some kind of a flare or some other magnetic effects coming from the larger star. And that's because this type of an orbital arrangement would just be completely impossible for longer than just a few years. if this planet was really orbiting between two stars, it would have already been kicked out a long time ago. But over the last 20 years, through continuing this research, and by using additional telescopes such as TESS and even Gaia, scientists discovered even more and more evidence for the existence of this unusual planet. Or at least for the existence of something gravitational tugging at one of the stars and producing these transient variations. And so here most researchers focused on one of two potential explanations. Either some kind of a new unknown phenomenon when it comes to stellar activity and stellar variability, which basically masqueraded as a planet, and if so, this was a huge discovery because it meant that many other planets are maybe also not real, or maybe this was a planet, but if so, orbiting in some really strange way, and for reasons still unexplained. And almost right away, the first explanation was that this arrangement seems to work if this planet is orbiting in the opposite direction, if this is basically a retrograde orbit. It would look something like this. And so it turns out that if it is orbiting in the opposite direction, suddenly things become a bit more stable, and suddenly this planet seems to be possible after all. And so with additional observations using various other telescopes, including Hipparcos and Rosette, researchers found more and more clues that there seems to be a planet after all, and the only explanation is that it's orbiting in the opposite direction. But despite the fact that these new studies explained how this planet was able to maintain its orbit, they didn't actually explain why it exists and how it was created. In other words, here, the idea behind the planetary formation did not make sense. Mostly because when planets are formed, they're supposed to be formed orbiting in the same direction as the rest of the star system, just because they're formed from the protoplanetary disk. And well, this mystery has been bugging researchers for essentially 20 years. For many years there have been different propositions and different explanations, but time and time again, something was discovered that just did not make sense. And so this very strange star, 70 light-years away from planet Earth, was creating a major problem for astronomy when it comes to orbital mechanics. But I guess the first question to ask here is, okay, well, how unlikely is this retrograde orbit? And do we actually have anything similar in the solar system, at least when it comes to, for example, moons or smaller objects? And the answer is yes. Here in the solar system, we do have quite a few asteroids, including the one you see right here, that seem to orbit in the opposite direction. As of 2025, approximately 100 such asteroids are known to us. You can find the list for some of them in the description below. And usually this is a result of interaction with planets like Jupiter that change the orbit of the asteroid so much that it eventually becomes retrograde. Intriguingly, in comparison, there are over 2,000 different comets known to have similar orbits as well. As a matter of fact, it's believed that some of these asteroids might have been comets in the past. But a much better example is the moon Triton, the moon orbiting Neptune. Here this is the only known moon to us that also orbits in the opposite direction, and today this is explained as this moon actually not being the moon to begin with. It very likely was a dwarf planet captured by Neptune billions of years ago, and at some point it's going to crash into Neptune because of tidal interactions. I think there are some older videos on the channel somewhere in the description discussing this a little bit more. And so maybe this planet experienced something similar to Triton. Maybe it was somehow captured in the current orbit from somewhere outside. Or to be more specific, it's extremely likely to have been captured from a much wider orbit when it might have been orbiting two stars instead of one. Here, for this capture to occur, the planet would have to change its orbit for many years, going through a kind of a figure-8 pathway around both stars until it finally assumes this orbit. In other words, this explanation was maybe just a little bit complicated as well. And so this orbit-hopping explanation was also not widely accepted. But because of some of the recent discoveries from other star systems, scientists potentially started to discover certain clues. For example, systems like this, WASP-17b, turn out to also have planets orbiting in a somewhat retrograde fashion, and planets that were potentially formed from some kind of a primordial disk back in the days. There were at least 2 such planets discovered in the last 10 years, but much more importantly, researchers also discovered a protostar or a baby star that contained an accretion disk where some parts were actually orbiting in the opposite direction, implying that the formation of planets orbiting in the opposite direction might happen in certain disks. And so this counter-rotating accretion disk actually became one of the best explanations. But the question is, where did the disk even come from? Well, it could not have been there from the start. It had to be a disk that formed afterwards when one of these stars became a white dwarf. And so here we actually have one of the biggest hints. The way this planet orbits, right between these two stars, is actually in the region where both stars very likely orbited around one another before the second star became a white dwarf. In other words, before the smaller star evolved into a white dwarf, and when it was still much larger, it was very likely orbiting much closer, which means that the current location for the planet would have been impossible, and that also implies that the planet very likely did not exist. But based on many observations from various white dwarfs, we also know that quite a few of them eventually form their own disks. Disks that sometimes seem to produce second-generation planets, with quite a few of these planets discovered in the past and quite a few of them discussed in the last few years. Actually, one of the recent discoveries even suggests one of these planets could have been inside the habitable zone sometimes in the past, which is essentially the final resolution to this 2-decade-old mystery that was recently explored and published in the study you see right here. And so after 2 decades and lots of observations, over 1500 to be exact, researchers seem to have finally explained what must have happened here. And so first of all, this planet is definitely real and was recently confirmed by the European Southern Observatory telescope, and this planet seems to have either come from the outside, much farther away from both stars where it orbited before, or more likely, was formed from the leftovers left behind by the white dwarf from that second-generation disk that seems to form around many white dwarf systems, which still makes this a very unusual and very bizarre system, but also a pretty exciting system because, technically, the way this planet orbits, depending on the type of a planet this is, it might have some really unique conditions on the surface, especially because it once in a while approaches the bigger star, where things become relatively warm. But since it's most likely some kind of a gas giant based on its mass, and since we know very little about it based on these limited observations, it will probably take a lot more observations and a lot more analysis to really find out what's going on the surface and to find out what kind of a planet this is. Right now its mass is estimated at 2.4 Jupiter masses, so it's extremely likely to be a hot gas giant. But we'll definitely come back and discuss this more if there are some additional discoveries and additional explanations. Until then, well, I guess it's great to know that this unusual ancient mystery is finally solved, and this bizarre orbit has potentially been finally explained. Hello wonderful person, this is Anton, and in this video we're going to discuss some of the recent discoveries from a somewhat unusual distant exoplanet, where for the first time ever, researchers were able to observe the entire atmosphere in 3 dimensions, allowing scientists to discover what's actually hiding here, and helping them finally understand what seems to be happening around this planet. And because this is a somewhat groundbreaking discovery when it comes to astronomical observations, mostly because this is the first time ever such an observation has been conducted, we obviously have to talk about this in more detail and discuss exactly what the scientists discovered and how this was achieved. But to start, let's talk about the planet first and the star system where it's located. And while by itself this is not a new discovery, this planet and the star system was officially described approximately 10 years ago, mostly because this was just another discovery of what's known as a hot Jupiter. The star system is known as WASP-121, with the planet now referred to as Tylos. It's one of those planets that eventually acquired a proper name. And Tylos, or WASP-121b, is an extremely hot gas giant orbiting super close to the star. Here, a single orbit takes just 30 hours, with the temperature on this planet being in thousands of degrees. But even though this is 900 light years away from us, since this planet is so close to the star, and since it passes in front of a star every 30 hours, it essentially makes it a perfect target to study planetary atmospheres. And back in the days, or basically 10 years ago, its discovery presented us with a perfect opportunity to try to find out what elements these planets seem to contain in the atmosphere, and if they were in any way similar to Jupiter and Saturn. Short answer, not really. Because almost right away researchers discovered a lot of unusual stuff here. Now first of all, there were signs of really powerful winds, but also chemical elements that we didn't really expect at first, and specifically heavy metals. Elements like iron and titanium were discovered almost right away. But because these observations at first were not very advanced, there was actually a bit of an argument in regards to what sort of metals this planet seemed to contain and what exactly was being discovered. And so for practically a decade, there was basically a kind of a back and forth in trying to identify the exact elements. But one thing was certain, this was the first exoplanet discovered to contain water, not like liquid water, but hot water vapor. This was most likely in the planetary stratosphere. And because this planet was a little bit more massive and a little bit larger than Jupiter, specifically 1.16 masses of Jupiter and 1.75 times its size, here it allowed us to see pretty much everything very clearly, but also presented scientists with a perfect opportunity to compare this to gas giants in the solar system. And the obvious first difference was the temperature, 2500 Celsius, 4500 Fahrenheit. This wasn't just a hot Jupiter, it was a super hot Jupiter, with some of the first observations of stratosphere revealing things like chromium, vanadium, magnesium, calcium, and of course iron and nickel. But also surprisingly, ionized sodium atoms. And here these unusual sodium detections were somewhat similar to what we kind of find around Jupiter when we see a torus created by Io orbiting Jupiter, as Io loses a lot of sodium as a result of volcanism, with some of the previous studies suggesting that something similar was happening here as well. The sodium here was possibly forming some kind of a gas torus, possibly created by some kind of an exomoon with Io-like emissions, but that exomoon was never officially confirmed, although we did talk about this in one of the previous videos in the description. But the additional observations using chemical analysis confirm that the atmosphere seems to be a little bit out of balance, as in it's actually escaping. And this was most likely because the planet was so close to the star, and it was also significantly larger than Jupiter, which suggested that it was very likely in what's known as the Roche loop of the parent star. Or in other words, the atmosphere of this planet was overflowing as the result of gravitational interaction between the planet and the star, and it was very likely the elements from this atmospheric loss that were being constantly detected by various observations. Likewise, surprisingly, this planet was discovered to be very likely blue in color, which actually suggested one really important thing. This was a direct indication of weather patterns. In other words, just like Jupiter and just like Saturn, there were definitely different storms and different atmospheric activity that researchers now were hoping to confirm. But intriguingly, some of the more recent studies from 2022 and 2023 actually had somewhat mixed results when it came to titanium. Some studies were detecting titanium, some studies were not seeing anything, and some studies were seeing titanium oxide instead, with something similar detected by other studies, especially when it comes to these heavier metals. And so something really intriguing was going on here, and that something was now discovered by these three-dimensional observations. Because now, for the first time ever, scientists were able to use 4 different instruments from the same telescope. Here we're talking about the Very Large Telescope, using the Espresso instrument, part of the European Southern Observatory, to essentially confirm that this planet had multiple layers, and it was really the different layers that we kept seeing previously. And so this unusual planet, Tylos, seems to be even more extreme than previously believed. And so in order to discover all of this, researchers conducted an observation of a transit with each of the telescopes focusing on a slightly different wavelength. And then by combining 4 separate observations into one single image, they essentially created a 3-dimensional representation of this planet's upper atmosphere, which revealed something like this. We have hydrogen on top, sodium in the middle, iron on the bottom. And so here the observations revealed 3 separate layers with 3 separate wind speeds, all containing different elements. And this was basically visible as very different elements with slightly different speeds. And since the top layer is hydrogen, it does suggest that this is a gas giant not so different from Jupiter and Saturn, but the layers underneath are very different. Here they discovered 2 additional speeds of 2 additional layers, with the middle layer containing that sodium, so basically there seems to be no moon here after all, the sodium seems to be coming from the planet and from its upper atmosphere, and we have iron underneath. This was basically the deepest of the layers. But more importantly, they also finally revealed that titanium once again, which basically suggests that a lot of these metals, a lot of these heavier elements, seem to represent some of these deepest levels, and seem to be visible sometimes, but not all of the time, which explains why they're sometimes invisible. Moreover, they also discovered a very bizarre jet stream that seems to spin the material around the equator of this planet, moving at super fast velocities. Here they refer to this as the equatorial superrotational jet stream. And what makes this jet stream so unusual is the speed. It seems to increase from about 14 km per second in the morning section up to about 27 km per second in the evening section. Now, because this planet is tidally locked, it basically always faces the same way toward the star, so the morning section here is always in the same region. But as this jet stream travels between the morning and the evening, it seems to increase in speeds so much that by the time it reaches the opposite side of the planet, things move at almost 30 km per second. That's way faster than anything we've seen on any planet, implying that the atmospheric conditions on this planet are really extreme. I mean, this jet seems to gain approximately 14 kilometers per second in speed as it travels from one side to the other, and that's just completely bizarre and difficult to explain. And this also seems to produce a lot of violent churning in the upper regions of this planet, which very likely results in this planet losing a lot of atmosphere. But everything here seems to be the result of the proximity to the star, because of the super hot temperatures on one side and slightly colder temperatures on the other side. We basically get these ridiculous speeds between the hotter and the colder sides. But what was surprising here is that it also seems to have layers, with researchers even comparing this to an onion. Not because it makes you cry, which I'm sure it would if you actually lived here, but really because it has these unusual elemental layers with various elements moving at different speeds and visible at different altitudes, with titanium and some of the heavier elements present and detected in the much lower levels. So essentially a lot of these heavier elements seem to be hidden by the upper atmosphere. But essentially this is the first time ever we've seen anything like this anywhere. This is the most unusual and the most unexpected observation of any planet outside of the solar system. The strange three-dimensional structure of a very hot Jupiter with layers of atmosphere moving at different speeds, and an extremely fast-moving jet right at the equator. But because this is just the first such observation, and because now we have the technique to detect this from other planets, the next step would be to observe other planets just to see if there's anything different there, or if this is actually some kind of a unique feature to a lot of these hot Jupiters. And so I'm actually excited to find out what they discover in some of the future studies, because for all we know, maybe this is how we can now define hot Jupiters. They're essentially kind of like hot onion planets. They contain different layers with different elements. Or at least this one is. Hopefully in the next few months we'll find out what the other planets are like from very similar observations. Hello wonderful person, this is Anton, and today we're going to discuss TRAPPIST-1 system once again, focusing on some of the most recent discoveries and some of the most recent studies, which essentially are all trying to answer the same question. Out of these 7 terrestrial planets, can any of them potentially host atmosphere and liquid water? And can any of them potentially host life? But as you might have learned from some of the previous videos from the past 2 days, based on a lot of recent observations, including the James Webb Space Telescope observations, one of the main conclusions so far has been that there is a very high chance that a lot of these planets are potentially entirely barren. This essentially could be some kind of a collection of really hot, dry rocks, basically containing nothing on their surface. Or at least these were some of the preliminary discoveries based on the observations from the TRAPPIST-1b and TRAPPIST-1c. And because stars like TRAPPIST-1, which are of course known as the M-type stars or red dwarfs, essentially make up something like 75% of all stars in our galaxy, compared to just 8% of G-type stars, which are similar to our Sun. If somehow this is true for all of these red dwarf systems, this would have a really big implication for the possibility of extraterrestrial life. But here there's also a really important side note. So far, detecting anything around planets in these star systems have actually been kind of challenging, and specifically detecting any kind of an atmosphere. And that's because red dwarfs actually complicate a lot of the analysis when it comes to the planetary spectrum. In many cases, because of the amount of star spots, they can actually be interpreted as something coming from the planet and not from the star, with many of these initial observations potentially being contaminated. Nevertheless, learning about this unusual star system approximately 40 light years away from us is of course very crucial if we actually want to learn more about terrestrial planets out there, and if one day we want to discover some kind of an extraterrestrial intelligence, or even just some kind of a simple life. And this is actually our first topic. Just a few months ago, researchers did actually take a look at this star system by using a radio telescope. And here there was obviously just one goal: detecting some kind of an alien technology, or some kind of an alien communication, by observing the star system for approximately 28 hours. But in this case they did use an extremely specific technique. A technique known as planet-planet occultation, which happens when one of the planets moves in front of the other planet and essentially presents us with a chance to potentially eavesdrop on any radio signals. And in this case, after these observations, they actually did discover over 2200 potential signals, way more than predicted. But upon thorough analysis, none of these signals turned out to be artificial in origin. Pretty much all of them had some kind of a natural explanation. And so here for planets B and C, the 2 closest planets to the star, we can almost certainly say that no one on these planets is trying to communicate using radio signals. But even though these planets seem to not have any extraterrestrial communication, based on some of the recent studies, they do potentially have a chance to have atmospheres. And this is based on at least 2 separate studies that have reanalyzed some of the data from the James Webb, coming to slightly different conclusions from initial analysis. And so, for example, for the closest planet, TRAPPIST-1b, something really exciting was actually discovered by analyzing different frequencies of infrared light. Now, first of all, based on the distance from the star, we know this planet is going to be really hot. At least as hot as Mercury, possibly as hot as Venus. But the initial studies from approximately a year ago, which you can learn about in some of the videos in the description, came to a conclusion that there doesn't seem to be anything on the surface either, as in no atmosphere and no possibility of any kind of water. And this was discovered by doing a really intriguing analysis when we actually observed the star and the planet by seeing different sides of the planet as it orbits the star. And so here, during the orbit, different regions of the surface are going to be emitting different amounts of thermal infrared light. And in this case, if there is any atmosphere, we are going to be seeing additional emissions in certain frequencies, even from the dark side of the planet. For example, if there is CO2 here, it's going to be emitting certain frequencies of light that should be detectable to the James Webb. And so in the study we discussed last year, based on the infrared observations in 15 microns, the overall conclusion was that there was no CO2, and the planet was most likely completely barren. But in this new study, also Ducrot and her team reanalyzed the data by also adding another wavelength, 12.8 micron. And turns out that here, the actual observations were just a little bit different. Instead of having a very strong and a very stable 15 micron signature, the 12.8 micron observations could only be explained as one of the 2 potential scenarios. Either this was a planet with a very, very young surface, less than 1,000 years old, and essentially a result of extreme volcanism, the so-called magmatic bare rock, or this planet was filled with hazy, carbon dioxide-rich atmosphere extremely similar to Venus. But it could not be a barren rock like previously assumed, which would actually produce different observations, and obviously it could not be an Earth-like planet. And that's actually a really exciting discovery because by using this new technique and new modeling, researchers actually discovered that the planet B might be a lot more exciting than we initially thought, with a 50% chance of having atmosphere or 50% chance of being volcanically active, with a process known as magmatic resurfacing, rejuvenating the surface every 1,000 years, which would also imply geologic activity, and that by itself would be super exciting. But if it does have atmosphere, it potentially has something extremely similar to what we actually observe on Titan. Here's actually how Titan, Venus, and TRAPPIST-1b generally compare to one another. But in this case, because this planet is extremely close to the star, the atmospheric chemistry would be entirely different, basically making this a really bizarre planet we currently cannot even imagine. Likewise, a somewhat similar discovery was also made about Planet C, the second planet from the star. A year ago, this was at first assumed to be also like an atmosphere, but a new analysis by Andrew Linkowski and his team, once again using very similar observations, focusing on 12 and 15 microns, also proposed a potential atmosphere that's just a little bit different from anything we imagined. And so even though this planet probably doesn't have a CO2 atmosphere, it might still actually have a really thick oxygen atmosphere, possibly as thick as 10 Earth atmospheres in terms of pressure. Or it can even be what's known as a steam atmosphere, where a type of a runaway greenhouse effect is basically driving liquid water into the atmosphere, turning this into a kind of a steam world. We've actually discussed these planets in one of the previous videos in the description. And so now Planet C also has a chance of having a really bizarre atmosphere on its surface. Just not the atmosphere that was previously assumed, and not the ones we're used to right here in the solar system. With several additional studies, such as this one by Joshua Christensen-Totten and his team, even proposing that other planets do actually have a really high chance to not just have atmospheres, but also liquid water. And specifically as a result of a secondary atmospheric formation that would very likely take a few 100 million years, but would basically result in hydrogen reacting with oxygen and iron and producing water, heavier gases, and a lot of important compounds in very large amounts on the surface. Now in this case, this is just a model and a potential explanation. There is no physical evidence, but based on this model, there is now new hope. A hope for these planets to maybe contain something interesting. And according to this model, planet TRAPPIST-1e, the one in the habitable zone, has an extremely high chance to have atmosphere and thus liquid water. And not just some liquid water, here we're talking about a huge ocean. So definitely a really exciting proposition. And one of the last studies takes this even a little bit further. Here, Afonso Mota and his team wanted to actually find out how likely is anything to survive on these planets, assuming that that something is exposed to superflares from a typical red dwarf and are basically living in these extremely hostile conditions. And the focus of the study was on something we know really well, Aspergillus niger, a type of a black mold that usually grows in soil that's actually known for producing a lot of melanin, that compound that basically gives us tan. And this mold tends to produce these really bizarre shapes where a large number of spores basically end up releasing peptidomelanin into the surrounding medium. In other words, they tend to produce the environment enriched in melanin, not just inside the cells but even outside of the cells. It's one of the most prolific producers of melanin, allowing it to survive extremely high levels of UV radiation. And so in this case, researchers wanted to basically simulate how likely is this mold to survive conditions around a star like TRAPPIST-1. In this case, this was done by simulating the environment and allowing these spores to grow in various saline solutions. And even when simulating radiation based on a superflare in a typical red dwarf, here the overall conclusion was that the spores would survive and would even thrive in certain conditions, although not if directly exposed on the surface. Here they would have to be either inside water or underneath millimeters of soil. But more importantly, the more melanin they produced, the more likely they survived, implying that technically life could exist here, and technically could live inside these oceans if they exist. But that's once again just a theoretical proposition and a theoretical analysis. Obviously, we're not going to know if there is any life here for a very, very long time. But despite all of these somewhat positive and somewhat optimistic studies, there is still one major problem with these red dwarfs. And it's not the fact that they have so many flares or produce so much radiation. It's also the fact that when these stars are much younger, or basically when M-types are just born and start to develop, they actually undergo an extremely hot stage in the early development that in theory could produce very hot conditions on the surface of all of these planets, which would last for hundreds of millions of years. And in theory, this would evaporate everything, turning all of these planets into just molten crust. And so basically, as of 2025, we still have absolutely no idea what's happening here, and whether any of these planets have anything on their surface, or if they can ever host habitable conditions. Hello wonderful person, this is Anton, and today we're going to discuss some of the recent updates about, I guess, one of the most exciting exoplanets discovered in the last couple of years. The exoplanet referred to as K2-18b, and exciting because of the observations from the James Webb that potentially revealed some of the first bizarre biosignatures coming from an exoplanet, possibly suggesting something alive on the surface, or maybe suggesting some bizarre chemistry. But ever since then, in the last year and a half or so, there's been a lot of additional observations and additional discoveries, and so I wanted to do a bit of a follow-up on what's happening with this exoplanet, and what most researchers believe now. But I guess first, a super brief review. First of all, this is called K2-18b, because this was part of the second mission by the NASA's Kepler telescope that conducted several observations around 2015. And during this time, even though it discovered a lot of exoplanets, one of them kind of stood out. And stood out because, first of all, it was in the habitable zone of the star system, and because its overall size suggested a potential terrestrial planet. But the additional observations revealed that this was very likely either a super-Earth or a mini-Neptune. So basically here, at a distance of 111 light-years away from Earth, we had an object with approximately 8.6 masses of planet Earth, and at least 2.5 times larger. But because the orbit here was 33 days, this was definitely in the middle of the habitable zone of this star system, with the average temperature potentially being slightly less than on planet Earth. Assuming this planet had no atmosphere, it would be about -8 degrees Celsius, but because of the atmosphere, it would be obviously much higher. But it was also discovered that this planet very likely has a much lower density than planet Earth, but much higher than Neptune. It was actually about 2.67 grams per centimeter cube, which was actually right between Neptune and planet Earth. And here this suggested some kind of a terrestrial planet, very likely surrounded by a thick atmosphere. And possibly atmosphere not so different from an actual gas giant. And actually this made this planet super exciting, with many additional investigations following for years after that. And the first one was obviously by the Hubble Space Telescope. Here, initially, Hubble seemed to reveal water vapor, which was already super exciting, with some of the first observations from the James Webb revealing carbon dioxide and methane. And this would make this a really intriguing world with potentially enriched atmosphere, but also potentially an ocean on the surface. And this made this planet one of the first members of the hypothetical Hycean planet group, a type of terrestrial exoplanets surrounded by a very thick hydrogen atmosphere, but also containing liquid water ocean on the surface, very likely enriched in hydrogen, and also very likely somewhat hot. You can learn more about this concept in one of the previous videos in the description. But apart from water, methane, and carbon dioxide, another study in December of 2023 revealed something else super exciting. In this study, researchers revealed carbon-bearing molecules, but specifically a molecule referred to as DMS, dimethyl sulfide. With this basically going viral because, in some sense, here, based on what we know about planet Earth, DMS seems to be mostly made by life, specifically ocean life, for actually somewhat unusual reasons that once again you can learn about in one of the previous videos in the description. And so a lot of astronomers started to wonder if maybe this DMS detection could actually be signs of life, possibly first ever biosignature coming from a distant planet. And since on Earth this is mostly produced by phytoplankton, being able to see it in the atmosphere of a different planet suggested that something maybe similar is going on there as well. And so mixed with the water vapor and the detection of carbon dioxide, this was super exciting. And exciting because normally, when it comes to biosignatures, we actually do want to find some kind of a mixture. So basically just finding oxygen or just finding DMS would not really mean much. But discovering things like oxygen, methane, and for example, nitrous oxides would be a pretty big deal because it would suggest this is very likely due to life. In this case, finding carbon dioxide, water vapor, methane, and DMS, though not a definitive sign of life, was actually super exciting, but obviously not a telltale sign of life, and the actual signatures and detections were not actually that strong either. In other words, these were just initial signs and not a definitive sign of something in the atmosphere of this planet. And here it's important to discuss a few additional discoveries and a few additional cases before we basically come to any conclusions. And let's start with Titan, the moon of Saturn. Prior to the Cassini mission, a lot of initial investigations of Titan also kept discovering bizarre molecules. I mean, we already knew it has methane, but here researchers also kept discovering CO2, carbon monoxide, and a few other carbon molecules, in many cases in very different proportions from what's expected from natural geology. Or essentially here, the atmospheric ratios of various gases didn't make sense. And so years ago, there were actually several papers making very similar propositions for potential biosignatures and maybe life on Titan based on these observations. And though obviously life on Titan is still technically possible, this was not the detection. And that's because once we saw Enceladus, the other moon of Saturn, things became way more clear. Enceladus, as you probably know, has these massive geysers. And these geysers, or technically these cryovolcanoes, play an enormous role in the entire Saturnian system. They're actually responsible for one of the rings of Saturn, but they're also responsible for enriching some of its neighbors. And so many of these plumes that shoot out water and a lot of other organic molecules basically end up enriching Titan with a lot of its carbon monoxide. And so this chemical imbalance seems to be the result of the cryovolcanism on Enceladus. It does not seem to do anything with life. And something somewhat similar was actually proposed here as well by a different study. Now, first of all, based on some of the older studies, in this case, this is one from 1975, we already knew that it's possible to create things like DMS in completely natural conditions without life. In this study, this was actually created using hydrogen sulfide, methane, and electricity, and absolutely no life was necessary. But a much more important discovery came from November of 2024. Here, a study by Nora Honey revealed that apparently dimethyl sulfide was also detected in comets. In other words, it's not just created by marine organisms, and there are actual natural abiotic sources in outer space, which means that DMS is definitely not a good biosignature to begin with. And since comets usually contain a lot of pristine organic molecules, it means that DMS can technically be created entirely without life. Here, we don't actually think life was responsible for the formation of DMS on the comets. In this case, this was based on the observations from the famous comet 67P Churyumov-Gerasimenko, which is actually a super important discovery, Since comets are so good at enriching a lot of different planets with a lot of different compounds, and potentially even delivering a lot of water to the surface of our own planet, it would not be unusual to discover DMS in some other star system somewhere out there, possibly delivered in the same way. So here, DMS does not require life at all. Likewise, some other studies try to explain these bizarre chemical signatures just by the fact that this is a bizarre planet. As in, because this is technically what's known as a Hycean world, mixed with a lot of other stuff, including hydrogen, that can no longer separate and creates a very strange mixture that occasionally releases certain compounds. And so this very strange hydrogen-water-based homogeneous liquid possibly just produces different chemistry we cannot imagine yet, mostly because the actual experiments of this liquid have never been conducted on Earth, just because it can only exist in some really extreme conditions. But a much bigger problem comes from something entirely different, and specifically from the way we actually discover all of this, and from the way this light is analyzed, and how we discover signs of these molecules. As you might already know, this is how it's actually done. Researchers basically look at the starlight passing through the atmosphere of the planet as it moves right in front of the star. During this passage, some of the light from the star basically creates certain absorption lines, which can then be interpreted as some kind of a molecule blocking the light. This then results in this absorption spectrum you see right here. But there's actually a problem here. A lot of this is technically guesswork. Light traveling through these molecules and the absorption it produces can technically be done by a lot of different stuff in different conditions. Or just to rephrase this, the same molecule can technically create a relatively similar absorption spectrum. And so in most cases, when scientists look at this, they actually have to make an educated guess. For example, based on the presence of something like methane, they might assume there might be some other carbon-based molecules, and thus assume that something here is, for example, carbon dioxide or dimethyl sulfide. But in reality, this data can have multiple interpretations. And so far, this has been the main criticism about the original paper. A lot of different scientists that use similar data from the James Webb Space Telescope decided to reanalyze it and actually ended up with different results. And one of the biggest such papers was just released. A comprehensive reanalysis of K2-18b's transmission spectrum. This is by Steven Schmidt and the international team you see right here. And here this was basically a kind of a summary of all of the different papers and all of the different techniques used to analyze this data that mostly came to a very similar conclusion. With the first conclusion being that there is indeed methane, and quite a lot of it. But based on the reanalysis and the use of slightly different statistical method, researchers found no CO2, no DMS. In other words, there does not seem to be carbon dioxide here, and there is definitely no signs of dimethyl sulfides. With the researchers concluding that this planet is very likely some kind of an oxygen-poor mini Neptune, and just has really thick atmosphere, very similar to Neptune, containing methane and a lot of other gases. But obviously because of higher density, it also does seem to contain a relatively large terrestrial core. And this is technically based on several studies from a group of different scientists that use different models to reanalyze this data and basically found no statistical evidence for anything like DMS. So essentially here, by using different methods, and specifically a much more thorough mathematical approach, a lot of these carbon molecules seem to completely disappear. And because in this case, mini-Neptunes or sub-Neptunes are actually some of the most common planets we've discovered so far, and they seem to be present in something like 1/4 of all star systems discovered so far, it would not be unusual for this planet to be somewhat similar. And so the result from the study basically suggests that this is very likely some kind of a sub-Neptune, also known as a gas dwarf. But we know that some of the coldest sub-Neptunes technically can host liquid water oceans, and this is what we refer to as Hycean planets. So basically there's still a slight chance that this is an exciting world and might even have a chance for life, but a lot of this would be complete guesswork and there is no evidence for anything yet.
Hello wonderful person, this is Anton, and today we're going to discuss a somewhat intriguing discovery of a completely new type of a planet we've never known existed. Although technically these types of planets very likely exist everywhere, we just had no idea these planets are possible until recent observations. And by itself, this discovery should not come as a surprise, because in the last few years, especially because of observations from the James Webb Space Telescope, astronomers have already confirmed several major new types of planets some with very exotic properties we actually didn't even think would be possible. And so let's talk about this new discovery and the study behind this and find out what this planet is like. A planet that potentially looks something like this. This is Gliese 1214b, but it also has a proper name, Anaiposha. A name it received a couple of years ago, because originally this planet was officially confirmed back in 2009, and even back then it was believed to be super exciting. And so yeah, this is not a new discovery of a planet, this is a discovery of a new type of a planet. Because turns out that this is not exactly what we thought. And in this case, this new discovery basically provides us with a little bit more evidence and a little bit more information about how these extreme planets form and how certain star systems seem to evolve differently from the Sun. But I guess here, first, let's talk about some of the recent discoveries of other planetary types, because in just the last 5 years or so, there's actually been quite a few studies defining new types of planets, usually based on their mass, their orbit, or their composition. Although in some cases by other classifications, such as for example the location around the galaxy. But essentially, as soon as space telescopes became operational and were able to capture planets and analyze them, we almost instantly started to discover bizarre planets. Planets that nobody believed or nobody could even imagine would exist somewhere out there, because approximately 2 decades ago, in the early 2000s, it was mostly assumed that most planets are going to be kind of similar to what we have in the solar system. But here, almost right away, scientists discovered super Jupiters, super Neptunes, mini Neptunes, and super Earths. These were actually some of the first discoveries from the Kepler telescope, and they actually seem to represent the majority of planets discovered so far, which was really bizarre. It basically meant that planets in the solar system are actually kind of rare. And so by mid-2010s, it was established that the majority of planets out there seem to be either super Earths or mini Neptunes. Basically planets a little bit smaller than Neptune, but much bigger than planet Earth, although not exactly like Neptune and not exactly like Earth at all. And so in total, over half of all planets discovered seem to fall into this category, with additional observations, especially focusing on orbits of these planets, also revealing additional types of planets based on their orbit as well. And while a huge number of planets turn out to be hot Jupiters, basically Jupiter-like planets extremely close to the parent star. These turn out to be so common that it was basically impossible to avoid them. But apart from hot Jupiters, researchers also discovered hot Neptunes, which potentially serve as some kind of a precursor for super Earths or for similar smaller planets. Likewise, approximately a decade ago, circumbinary planets were confirmed as well. This is basically a planet orbiting 2 stars at the same time. All of these discovered in just the last decade or so. Lastly, some of the most exciting discoveries when it comes to new types of planets were also based on their composition. For example, extremely recently, researchers finally confirmed Chthonian planets. Planets that basically used to be very likely gas giants or possibly Neptune-likes, but eventually evaporated all of their atmosphere, leaving behind a terrestrial core. These planets were hypothesized for a very long time, but they were officially confirmed not so long ago, and a lot of videos in the description should explain this in more detail. Then, in the last couple of years or so, scientists have also confirmed 2 very unusual types of super-Earth planets that basically have very strange composition that was somewhat difficult to explain. One of these planet types is known as the Hycean world. Basically, a bizarre super-hot planet with potentially supercritical water on the surface that, though contains oceans and potentially very deep oceans, might actually be too hot and too extreme for life to survive. Likewise, just a few months ago, there was also confirmation for what's known as a steam world, a somewhat similar concept but with a planet that basically has steam atmosphere and very likely oceans that are also kind of extreme. Once again, the videos in the description describe these planets a little bit more. But one of the more mysterious types of planets was known as the Poofy planet, with some of the bigger examples known as super-poofs. In a nutshell, in terms of mass, these were very similar to Jupiter and sometimes Saturn, but their size would be dramatically larger. They were basically kind of like expanded or poofy Jupiters, which is why they started to be called Poofy planets. And their expanded atmosphere basically didn't really make a lot of sense. It was not clear why they had such a low density and why they were inflated to such a large degree, especially because their inflated atmosphere didn't really make much sense. Here's for example one of the first such discoveries, TRAS 4b. And I guess what's even more surprising is that none of these unusual planets, many of which have been discovered in other star systems, seem to have ever existed here in a solar system, and exactly why was not clear. And so because these planets were so different from anything we have, it was obviously difficult to guess how they were formed, or even what they're made out of, or what's in their atmosphere. But as I mentioned, one of the most common types of planets is basically either a super-Earth or a mini-Neptune. And even today it's not entirely clear if this is actually two types of planets, or if it's just a much larger category of the same type of a planet that seems to be both larger and more massive than planet Earth, but much smaller and much less massive than Neptune. And so for many years now, researchers have basically debated what sort of a composition we're going to find on these planets, and what kind of an atmosphere they would have as well. For example, is this basically some kind of an Earth-like planet with a very expanded hydrogen-rich atmosphere, and thus high pressure and potentially high temperature? Or would this be something very similar to Neptune, containing a lot of icy components, including water-rich atmosphere, and potentially a lot of haze, and a lot of organic compounds, both on the surface and inside the atmosphere? And so obviously there were quite a lot of models and quite a lot of simulations, but no actual evidence yet. And that's because atmospheric spectroscopy, which is required to determine all of this, was still in its infancy. But in the last few years, techniques in atmospheric spectroscopy suddenly became advanced enough to help us see what's inside. And this is basically both because of James Webb Space Telescope, but also because of the Very Large Telescope, part of the European Southern Observatory, which has a bunch of instruments that allow us to measure planetary spectroscopy directly from planet Earth. And so in a couple of new studies, Kazumasa Ono and Everett Schlavin, along with their teams, conducted a relatively detailed observation of the planet known as Gliese 1214b in order to determine what this particular super-Earth contained on its surface, and if it was basically some kind of a water world, hazy Neptune-like world, or some kind of a very large terrestrial planet. And here once again all of this was done in a very simple way. By observing the light from the star as it passes through the atmosphere of the planet, which we can kind of simulate right here using Space Engine, it becomes possible to actually see spectroscopy of various elements in the atmospheric layer, allowing researchers to determine what the atmosphere contains and what it's like on the inside. And so here, by using James Webb Space Telescope, they focused on one of the easiest planets to observe that's approximately 48 light-years away from the Sun. And previously this planet was potentially believed to be some kind of an ocean world, or basically some kind of a water world, with possibly very thick, very large clouds, that was actually officially discovered back in 2013 during some of the first observations. But here it was not entirely clear what kind of clouds these would be, and more importantly, if this planet could actually contain water after all, and basically be some kind of a really massive water world with maybe once again supercritical water. And so because this object is relatively close to the Sun, and because it transits in front of the star, here this was a perfect target for the James Webb. And one of the first discoveries in terms of spectroscopy was actually carbon dioxide, with potentially also signs of methane. So basically by observing this in 2.8 to 5.1 micron, researchers discovered definitive signs of CO2, methane, and basically atmosphere that's high in metallicity compared to some assumptions that maybe it was actually hydrogen. So essentially James Webb confirmed that this was not a hydrogen planet and did contain a lot of carbon-based molecules. And then by using modeling and simulations, they were able to recreate at least one example that seemed to fit the observations pretty well. And so here the theoretical models seems to predict that this is actually an extremely rich in carbon dioxide planet with very hazy, very thick atmosphere, somewhat similar to Venus. As a matter of fact, it might be as dense as Venus itself, with extremely high pressures on the surface and basically haziness that prevents anyone from seeing the surface from the outside. But because there was also a detection of methane, in some sense this planet might also resemble Titan just a little bit. Although technically both Titan and Venus do actually kind of look alike. But in essence, what this means is that we now have a new type of a planet, and it's basically now called Supervenus, a carbon-dominated atmosphere containing very hazy, very thick clouds that instead of being rich in hydrogen or water vapor, seems to be basically enriched in carbon dioxide and methane through obviously processes we don't really understand yet. And obviously if this planet is as thick as Venus, it possibly also contains very extreme conditions on the surface, but maybe even contains enough pressure and temperature to basically turn carbon dioxide liquid. And that's because in certain pressures and certain temperatures, carbon dioxide becomes liquid and even becomes superfluid, allowing it to do a lot of bizarre things. And so basically here, we might even have some kind of a liquid cycle, and possibly even oceans, but not oceans of water, not even oceans of methane like on Titan, instead oceans of carbon dioxide. Which is why this is indeed a new type of a planet, a Supervenus. Kind of like a mixture between Titan and Venus, but much more extreme. Although technically this planet could also contain other stuff as well. There might still be some hydrogen, maybe some water vapor, and possibly even helium. So future observations will probably tell us a little bit more.
Hello wonderful person, this is Anton, and in this video we're going to be discussing another unusual exoplanets discovered in some of the recent data. But this time it's once again one of these impossible planets that are technically not supposed to exist because of the way we think planets are usually formed. And specifically because this planet is just way too big compared to this star. Yet based on the observations, it's definitely there, and it's actually quite extreme. And so let's discuss why this is so interesting, what we know about these planets so far, and what all of this means. But first, let's start with a brief overview when it comes to exoplanets discovered so far. And while out of thousands and thousands of confirmed exoplanets discovered in the Milky Way, surprisingly only 10% of them seem to be orbiting red dwarfs, also known as M-type stars. Yet when you look at the galaxy as a whole, M-type stars represent the majority of stars. M-type stars are 80% of all stars. And so for some bizarre reason, there's a bit of a discrepancy between the number of planets we find around them compared to what's expected and compared to what's predicted. But according to modern theories, we actually expect mostly terrestrial planets orbiting these M-type stars. As a matter of fact, the majority of terrestrial planets should be orbiting red dwarfs and not other stars. And so far this prediction has been more or less correct. For example, the famous TRAPPIST-1 system contains 7 such planets, with quite a lot of other terrestrial planets predominantly discovered around M-type stars. And that's of course the result of modern predictions when it comes to star formation. Pretty much all of the planetary systems we've seen so far are expected to form from the protoplanetary disk. And normally this disk evolves and even collapses in a very similar fashion, eventually resulting in somewhat similar planets depending on the initial mass of the disk. And so a massive disk with a massive star is going to produce really massive planets. Likewise, a smaller disk is going to produce something smaller and is extremely unlikely to produce a massive planet. And so studies like this from 2023 essentially suggested that gas giants in red dwarf systems seem to be practically impossible, with maybe only about 1.5% of all red dwarfs containing some kind of a relatively giant planet. But the presence of any gas giant around a red dwarf kind of suggests that the standard model of planetary formation may not be entirely correct, because it doesn't really explain how such planets could form. But based on some other theories and some other predictions, we also know that one of the main reasons Earth is the way it is, and one of the main reasons life potentially even formed on Earth, is possibly because of Jupiter. Jupiter possibly set the stage for Earth to become habitable, causing the planet to form in a certain way, to have certain size, certain composition, and even acquire water. There should be some older videos in the description that discuss this in more detail. And so since red dwarfs are unlikely to have these planets, it may also suggest that rocky planets around red dwarfs would unlikely to evolve into Earth-like planets hospitable to extraterrestrial life. Or at least that's basically the hypothesis behind all of this. But surprisingly, in the last few years, this hypothesis may have been proven incorrect several times. And that's because over the years, at least a few planets have been discovered around red dwarfs that seem to be just a little bit too large. So for example, here's a comparison between Sun and Earth, and here's a comparison between a planet known as LHS 3154b and the red dwarf it's orbiting. Here the size of the planet doesn't actually make sense because the star is really small. Or here's actually one of the most extreme cases, Gliese 3512b. Here the mass ratio between the planet and the star is approximately 270. Or basically the star is 270 times more massive than this planet. But if you compare this to the Sun and Jupiter, the ratio is closer to 1050. And so it's not entirely clear how such red dwarfs can produce enormous debris disks, allowing such massive planets to form. which is a kind of a planetary formation anomaly. Here's another example. Gliese 581 seems to also contain a few planets, with at least one of them having a mass similar to Neptune. And here the total mass of planets does not make as much sense because the star is really small, with the star known as Gliese 876 potentially being one of the more extreme examples, and even one of the more intriguing examples, because here we have 4 planets, with at least 2 relatively close to the habitable zone, but one of these planets being approximately 2.3 times mass of Jupiter. Way more massive than expected, because the star, as you can see from this comparison, is much smaller than the Sun. And so over the years, a few of these planets started to create this bizarre anomaly that even today does not have a very good explanation. And now we officially get another planet, but this time even more exciting than before. This is known as TOI 6894b, a planet that seems to be 86% the radius of Jupiter, once again orbiting a red dwarf that's only 20% the mass of the Sun. And this is actually the smallest star we've ever seen to contain any gas giant. As a matter of fact, this planet is so large and the star is so small that when this planet was discovered, it actually produced an enormous dip, or an enormous shadow around the star, making the star dim by approximately 17%. And that's because this planet was discovered by using the transit method. But this transit was absolutely not expected. Researchers have actually never seen such a large dip anywhere, which would essentially suggest that the star is roughly around 320,000 kilometers across, and the planet is 120,000 kilometers, so approximately a third of the size. But we still didn't know its mass until recently. And so in this study, Edward Bryant and the team you see right here discovered as much as possible about this planet by also using the European Southern Observatory's Very Large Telescope in order to figure out its total mass. Here this is using what's known as the transit velocity method, using the espresso instrument, which allowed researchers to establish the periodical redshift and blueshift changes as the planet orbits the star. And turns out that it's not that massive. It's approximately half the mass of Saturn, or 17% of Jupiter. But because it's so large, it implies that this planet is very puffy and very extended, which also makes this a perfect candidate for atmospheric studies. Because it becomes such a large object when passing in front of the star, it means that the atmospheric composition of this planet can be easily captured and analyzed by most of the telescopes we usually use for this, including the James Webb. And some of the preliminary observations suggested that this planet seems to be dominated by methane. But there's also potential signs of ammonia, which technically would be the first time we've ever seen ammonia on any exoplanet. But obviously there's still a major mystery. Nobody has any idea how such a tiny star can form such a massive, large planet. And that's because based on a lot of observations of various baby planets and various growing star systems, we generally have certain expectations about what should be produced around what type of a star. And while the smallest stars are expected to have the smallest planets. Yet here we seem to have a giant that makes no sense. Which once again suggests there seems to be some kind of an anomaly, or maybe we just lack general understanding and general knowledge when it comes to planetary formation. But so far, out of 91,000 low-mass stars observed by the TESS telescope, this seems to be the most anomalous example of a really small star with a very large planet. A planet of unknown origin. But luckily in the next few months, we're most likely going to have observations from the James Webb Space Telescope that will allow us to see the atmosphere and potentially even the distribution of material inside the atmosphere, offering a few clues about the formation of the planet just based on what we find inside. And so for all we know, maybe this used to be several planets that combined into one, and this whole puffiness comes from the fact that this is just a really hot object that expanded over time following the collision. But even then, this still doesn't make sense because the total mass of the protoplanetary disk would still be a little bit too massive for such a small star. Hello wonderful person, this is Anton, and today we're going to discuss some of the recent updates, and actually somewhat exciting updates, in regards to one of the closest stars to the solar system. The star you see illustrated right here, known as the Barnard star. And a star that we actually discussed not so long ago, approximately 5 months ago actually, because scientists finally discovered and confirmed at least one exoplanet in its orbit. But in this new study, researchers now officially confirmed 3 more, essentially making Barnard star one of the most exciting star systems close to us, and essentially the closest multiplanetary system officially confirmed. But because the star system here is kind of interesting and somewhat unusual, it's worth exploring these discoveries once again in a little bit more detail. And I guess here a super brief summary of that previous video that should also be in the description below, just so that you understand why this discovery is kind of exciting. In essence, Barnard star, that's only about 5.96 light years away from planet Earth, represents one of the most studied red dwarfs in the entire galaxy, mostly because it's so close to us, and because, by distance, this is the fourth closest star to the solar system. The three other stars are Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. And though Proxima Centauri is the closest red dwarf, and Proxima Centauri seems to contain two of its own exoplanets discovered not so long ago, once again videos in the description talk about those planets as well, Barnard star is just a little bit different and a little bit more unusual for at least a few reasons. First of all, one of the main reasons it was even discovered is actually because it's moving so fast across the night skies. It basically has the fastest proper motion of any known star. Here it's close to about 110 kilometers per second. And this is exactly how it was originally discovered by Edward Emerson Barnard back in 1916, which is why the star is named after him as well. But the fast motion is not as exciting as the age of the star, because strangely enough this also appears to be an ancient star. It's believed to be at least 7 billion years old, but could possibly be up to about 12 billion years old, and has even been suggested to be one of the oldest stars in the entire galaxy, which is why researchers really wanted to find something around it, a planet, any kind of a planet. Mostly because it was also believed to be very low in metallicity. Some of the initial observations suggested that its metallicity is about 10% of the Sun, or in other words, it contains only 10% of non-hydrogen and non-helium compared to the solar system. And so many different models suggested that maybe it just does not have enough material to form any planets, and possibly only contains a bunch of smaller objects, such as for example dwarf planets and asteroids. And for many decades, researchers tried to find any planets here, and though some planets were initially suggested to exist, they eventually all turned out to be nothing. There were no gas giants here, no super-Earths, nothing large, nothing exciting. Here's actually where the star is located, compared to some of the other objects, such as the Alpha Centauri Proxima Centauri systems, and the brown dwarfs known as the Loman 16. But one of the reasons researchers knew this is an ancient star is because of the way it was spinning around. Its rotation was extremely slow, taking something like 140 to 150 days, which basically implied that it's super old as well, mostly because we know that as stars get older, they usually start spinning slower and slower. And to researchers, this meant that if there are any planets here, especially in the habitable zone, maybe this would be a perfect star system for basically a long-term habitable system. Mostly because it was always believed that as these red dwarfs get older, they become extremely mild and eventually become perfect star systems. And all of this was proven to be completely incorrect in 1998. Because in 1998, for the first time ever, astronomers observed a massive stellar flare coming from this star, and it was so powerful that it actually increased the temperature of the star by at least 4000 Kelvin, essentially doubling the temperature for a brief moment. And this was such a powerful event that this essentially changed everything. To scientists, this implied that any planet in the vicinity of the star would very likely be completely stripped of everything, because these solar flares turned out to be a lot more common, because very similar flares were once again detected in 2019, although this time mostly visible in the X-rays. And so Barnard star turned out to be a flare star, a star capable of producing massive eruptions, and a star that would produce so many powerful plasma ejection events that any atmosphere or any liquid water would unlikely to exist in the habitable zone. Here scientists even calculated the approximate atmospheric loss for a typical planet, discovering that approximately 90 Earth atmospheres would be stripped of any planet every billion years. But they still wanted to find some kind of a planet, just to see if they can even exist in these hostile conditions. And especially because some of the more recent calculations even suggested that maybe the star's metallicity was actually a little bit higher, possibly 75% of the Sun and not 10, which would imply it could possibly host smaller terrestrial planets. And so the search continued, and as we discussed in that previous video, for the first time ever, researchers finally discovered the first ever exoplanet discovered around a typical population 2 red dwarf star, a planet known as Barnard B. This was officially confirmed in August of 2024 by using a spectrograph known as Espresso on top of the Very Large Telescope, and was found to be approximately 0.37 masses of planet Earth with an orbit of 3.15 days. And so even though it was orbiting very close to the star, it was nevertheless there. Here, the temperature would be at least 165 Celsius, 330 Fahrenheit, assuming there is no atmosphere. If there's any atmosphere, the temperatures would be much higher. And this was super exciting because it basically suggested that planets around these red dwarfs, despite low metallicity, are definitely possible. But obviously not massive planets. Here this was just a little bit larger than Mars, but even smaller than Venus. But the thing is, we didn't really know much about this planet because it was discovered this way. This is a radial velocity method, where researchers essentially observe the star and try to find tiny wobbles, mostly based on the redshifts and the blue shifts of the star's color, by observing the star long enough to see periodic changes. And though years ago this would be impossible because the technology just didn't exist yet, Taiwanese new instruments like Espresso allow us to measure extremely tiny deviations, thus allowing researchers to discover these super small planets. But in the study, they also mentioned that there might be 3 more candidates. It wasn't clear exactly where they are or if they even existed, but there was a bit of a hint. And the candidates would also be potentially rocky planets, because in this case this is also believed to be a rocky planet, since it's the only way we can explain such a close proximity to the star and such a low mass. In terms of size, it's believed to be about 75% of the size of planet Earth. But these first observations did not reveal much else, and more importantly, no transits have been found. Observations by the TESS telescope discovered no shadows, which meant that the overall calculations would be very limited. And that's until now, because a completely separate team using a completely different instrument decided to do something very similar, but also decided to basically ignore previous data and see if they can actually either confirm this or possibly disprove this. And here they use something very different. Maroon X instrument attached to the Gemini telescope in Hawaii, and the instrument that's specifically designed to look for various planets. But once again, it works in a very similar way. Instead of looking for the shadow, it looks for tiny deviations in the orbit by looking at the redshifts and the blue shifts. And so here, once again, it discovered a bit of a wobble. Now, because the star is actually pretty massive and these planets are not that massive, the wobble was very small. You can actually see it in this graph right here, and basically here, each of these planets would change the star's velocity by approximately 20 to 45 centimeters per second. Or in other words, because the planet in this case is pulling on the star would move just a little bit this way, then the other way, with the overall change of velocity only being in centimeters per second. That's how ridiculously accurate this instrument is. And that's because the mass of each planet creates its own gravitational pull that then influences the star. But when all of the observations were combined, scientists discovered definitive signs of certain patterns, implying that something was pulling on the star in a very certain way. And that something had to be 4 separate planets, but each of them very small, possibly about 20 to 30 mass of planet Earth. So essentially planets a little bit more massive than Mercury and Mars, but less than half the mass of Venus. And each of them surprisingly very close to the star. The closest one was orbiting every 2.3 days, the farthest one every 6.7 days. So none of these planets were even in the habitable zone. Although planet E in this case, because it's much smaller and much less massive, is actually kind of exciting. It does have a slight chance to potentially be just cold enough and just small enough to maybe have something exciting on the surface. And so after 3 years of observations, specifically during 112 different days, there was enough evidence to confirm all 4 planets. 4 rocky planets around one of the closest star systems near us. And because this discovery was made completely separately from the previous discovery, using different methods and different telescopes, here this actually gives us a lot of hope that this is indeed what's there. But once again, because currently it's almost impossible to see these planets directly or to analyze their shadows, unfortunately there's not much else we're going to know about them for quite some time. Just measuring their mass is unfortunately not enough, and not being able to observe their shadow as they pass in front of a star implies we're not going to be able to study their atmospheres or even study their surface, or at least until something else comes out or some new discoveries are made. But here this new study also does a few more things. First of all, they also confirmed that there seem to be no planets in the habitable zone, specifically no planet larger than 57% of the mass of planet Earth. There might be something smaller, but nothing has been seen so far. And so it's quite certain that Barnard star doesn't seem to have any larger planets in its orbit. Likewise, it's actually really surprising that the smallest planet was even discovered, because currently the smallest and the farthest planet, that's only about 19% the mass of planet Earth, is actually the least massive exoplanet ever discovered using the radial velocity method. and its pull on a star is so tiny that it only causes the change of velocity of about 22 centimeters per second. Just a few years ago, it would be impossible to see it using any telescope. But both studies suggest that all 4 planets seem to be definitely there, and surprisingly, they seem to be kind of small. But because once again this is an ancient star system, and because its metallicity is lower than the Sun, this is also exciting because it confirms that these population 2 stars, which were very likely created a long time ago, seem to also be able to form terrestrial planets. In other words, confirming that terrestrial planets could have technically existed extremely early in the universe, because it's quite possible that these planets formed as far back as 12 billion years ago. We don't really know their exact age yet, but chances are, because the star is once again so exciting, we're going to know much more about it in the next few years. Hello wonderful person, this is Anton, and today we're going to discuss some of the recent updates in regards to these bizarre worlds referred to as Hycean worlds, mostly because recently there was a story that went viral in regards to the potential discovery of life on one of these distant exoplanets. And here we're of course talking about the K2-18b claim that was basically mentioned by every major media source. You can learn more about this in one of the videos in the description, but in a nutshell, despite the claims from Cambridge University and the way that media presented this, right now the enthusiasm for discovering life on this exoplanet is basically a little bit too much. We'll actually talk about this next week because there have been some other updates, but here even the famous Sarah Seeger, who was actually graduate advisor for Niku Madhusudan that published the paper behind this claim, basically stated that in this case, enthusiasm is outpacing evidence. Or in other words, there's obviously a lot of exuberance and a lot of excitement, but the evidence is just not there. Because in this case, this is probably just one of the possible interpretations of the data collected from the James Webb Space Telescope. And so because of this, I wanted to discuss a relevant claim coming from Niku Madhusudan when he actually proposed the idea behind Hycean worlds. Basically these really bizarre planets, larger than Earth but smaller than Neptune, that would contain an extremely thick hydrogen atmosphere, but also an enormous global ocean. Here he presented them as these enormous ocean worlds that he also believed might exist everywhere, just because of how common mini Neptunes are in general. And so in 2021, he coined the term Hycean, or Hycean planets, basically hydrogen ocean planets, with the one he examined the most being K2-18b. And so according to his proposition, or I guess according to this narrative, here our galaxy might be actually filled with these really bizarre, extremely large ocean worlds containing enormous oceans, but also containing conditions that could be hospitable to life, at least some types of life such as microbial life. And at least one of these Hycean worlds, K2-18b, he now claimed contained life after all. This was basically that claimed detection of DMS or dimetyl sulfide. And yeah, once again, check out the videos and stories in the description if you'd like to find out the details. But K2-18b was just one of several candidates proposed to be somewhat similar. As a matter of fact, there are at least 3 more. TOI 732c, where TOI stands for Test Object of Interest, also TOI 1468c, and the most exciting one, TOI 2070d. And back in 2024, Madhusudan himself proposed that TOI 27d was very likely also a Hycean planet, another large ocean world with possibly also conditions supporting life. That was the claim from the paper he wrote in 2024. And because these planets were just as exciting as K2-18b, a lot of researchers wanted to take a look at these planets with the James Webb in order to see what's going on the surface and in the atmosphere, and to most importantly see if they can also find additional signs of potential life, such as maybe DMS again, I guess. And here, TOI 2070d was actually even more exciting. It was around a relatively quiet star, and it also contained 3 sub-Neptune planets, with maybe even all 3 being kind of similar, and maybe even being these ocean worlds. But it was only C and D that were the most likely candidates to be these Hycean worlds. 270d was the strongest candidate. This was a planet 4.2 Earth masses and approximately 2.1 Earth radii, and was orbiting a red dwarf star every 11 days, which was actually close enough to have really solid atmospheric observations. And while the initial insights suggested, once again, hydrogen-rich atmosphere, and maybe evidence of water in the atmosphere as well, which of course meant that we had to take a look at this planet again. And this is what was recently done after years and years of speculations. This was recently reported by Christopher Glein and the team right here, in a study deciphering sub-Neptune atmospheres, insights into geochemical models on TOI 2070d, an extremely thorough analysis of the atmospheric composition that focuses on comparing various models to what was actually seen, and even focusing on the exact amount of stuff detected and explaining why certain things were actually missing. And this whole analysis is based on what's known as thermochemical equilibrium, basically inferring conditions for how certain chemicals can form and what pressures and temperatures are required to create these specific concentrations. And while these new observations first of all reveal that this planet is strongly enriched in both carbon and oxygen gas in comparison to hydrogen, but its nitrogen is extremely depleted and possibly even missing. And this was actually a mystery for quite a while now, because compared to previous assumptions about these planets and compared to what we see around Neptune and Uranus, here it was actually believed that it's going to have a lot of ammonia. Ammonia contains nitrogen. And ammonia is expected to be present in Neptune-like planets, but for some reason, warm sub-Neptunes or even hot sub-Neptunes seem to lack it, with previous models suggesting that there should be a lot of it because of really hot atmospheres extremely rich in hydrogen gas, and especially if there's some kind of a global ocean, as previously claimed and as suggested by studies in regards to these being Hycean worlds. But the exceptional modeling and the explanation in this paper basically presents us with something entirely different. And good news, it might be a rocky planet. Bad news, it's an extreme rocky planet. A giant rocky planet covered in extremely thick hot atmosphere that seems to contain a magma ocean. And so yeah, this is maybe a lava planet. And it's really because of this lava that scientists can now explain why it doesn't seem to have ammonia. Because here ammonia is depleted through a combination of planetary processes and basically turns into nitrogen gas at high temperatures, while then combining with the superheated magma ocean on the surface of the planet. And while the thing is, the observations from the James Webb seem to actually match this model directly. But naturally this planet would be way too hot for the actual ocean to exist. And instead it seems to contain a very unusual gas equilibrium in its atmosphere, specifically carbon dioxide methane equilibrium, that seems to occur at very specific temperatures between 900 to 1100 Kelvin and at pressures of 1 to 10 atmospheres. In this image it's seen as this hot gas at chemical equilibrium, which essentially creates this very hot and very unusual atmosphere where there's not a lot of chemistry, and instead the atmosphere achieves an equilibrium where most gases seem to remain in the same amount. And the additional observations from the James Webb also confirm that some of these gases can only exist at super high temperatures, so basically 900 to 1100 Kelvin. Otherwise these gases should not be possible. But surprisingly, the atmosphere is still enriched in water vapor in comparison to carbon dioxide. Here this is explained by a process known as water-gas shift reaction, with pretty much every gas detected by the James Webb explained in the same way. And so, in a nutshell, this giant rocky planet, covered by extremely hot, thick atmosphere, seemed to explain these planets much better than the Hycean planet hypothesis, which is also one of the conclusions in the paper. Here the results imply that the Hycean hypothesis is currently unnecessary. And though they don't disagree they might exist, the main conclusion in this paper is that K2-18b and TOI 27d are not Hycean worlds. They're more like high magma worlds, or I guess high lava worlds. Oh hey, I like that. High lava. Basically hydrogen lava worlds. Very hot rocky worlds with a magma ocean covered by extremely thick hot gas. And here even the upper atmospheric conditions seem to be kind of hot. 400 Kelvin is above the boiling temperature of water and is about 120 Celsius or 260 Fahrenheit. But because this planet is so close to us, this is still one of the most exciting such objects because it allows us to understand exactly what these types of planets are, and of course helps us understand if life can maybe exist here. Right now it doesn't really look so, because this is more of an extreme version of Venus. But because these sub-Neptunes are so common and so different, for all we know, maybe somewhere out there might be a Hycean planet after all, just not one of these. And though some I guess could be habitable, we have no evidence of this yet, and we have no evidence that any of this exists either. Based on decades and decades of research and a lot of observations across the universe, even to date, Earth is still the only known planet to us that definitely contains life. And that's despite the fact that thousands and thousands of different exoplanets have already been confirmed. But despite these large numbers, It's really only the handful of exoplanets scientists are currently trying to investigate because of a relatively high potential for extraterrestrial life to maybe exist there. And well, in this video, we're going to discuss a relatively recent and somewhat intriguing discovery that was done by using a very unique method when looking for exoplanets. But even more interestingly, when scientists discovered this planet, they realized it was actually in the habitable zone of a star extremely similar to our Sun. And so let's talk about this recent study and these recent discoveries. But first, let's actually start with some of the previous discoveries, just to help you understand how all of this is surprisingly extremely rare. Although first, a quick clarification. Here we're only talking about planets located in habitable zones of various stars. And that's because, based on the example of planet Earth, we know life can definitely exist if a planet is at a certain distance away from the star. And so depending on the star, this zone is going to be in very different locations. And so until we actually find life somewhere out there, for example maybe on some other planet like Venus or Mars, or maybe even on one of the moons of Jupiter, we're still going to have to rely on this habitable zone because this is the only certainty we have. This seems to be the only location in a star system where liquid water can exist and conditions can be perfect for life to evolve. And well, based on what we've discovered so far from other star systems, and based on what we know about our own galaxy, today it's believed that at least 40 billion Earth-like habitable planets, or at least Earth-sized planets, could possibly exist somewhere in the Milky Way, basically orbiting in these habitable zones around Sun-like and red dwarf stars. Except that in some of the recent studies, scientists also realized that maybe red dwarf stars, which are the most common types of stars in a galaxy, could be just a little bit too active and possibly too dangerous for any life to survive. And so if we ignore red dwarfs, and if we only focus on Sun-like stars, at least 11 billion such planets should be hiding in the Milky Way. But as I mentioned, surprisingly, only a handful of these planets have so far been confirmed in the vicinity of the solar system. And so out of several dozen habitable exoplanets discovered to date, only a very small number seems to orbit Sun-like stars. And there are so few of them that it's only going to take me a couple of minutes to basically cover all of them. Here's the illustration for the first one, Kepler 452b, previously referred to as the Earth's cousin in some of the initial press releases. And in this case cousin because it's actually much more massive than Earth, at least 5 masses of planet Earth, but orbiting at a similar distance away from the star, and back then representing only the second planet discovered around a G-type star located in the habitable zone, although this was back in 2015. Since then, a few more planets have been discovered. But the problem is that this planet is also really far, over 1800 light years away from us, so studying this would be very challenging. And so in contrast, we have this, Tau Cetus F, another super-Earth orbiting a Sun-like star, but much closer to us, only 12 light years away, around a famous star known as Tau Cetus. You can actually learn about the star in one of the videos in the description, because it is a very exciting star system and seems to hide quite a lot of mysteries. And so at 4 Earth masses, and potentially slightly colder than planet Earth, this planet is pretty exciting. Then number 3 is HD 20794d. This is a little bit farther at 20 light years away, but surprisingly is also a super-Earth, at least 6 times more massive than planet Earth. And this one is also unique because it only passes through the habitable zone once in a while and seems to contain a somewhat eccentric orbit. The star system also contains a few other planets, and so here there are quite a lot of mysteries as well. And then we have Kepler 22b, representing the smallest planet discovered in the habitable zone at only 2.3 sizes of planet Earth. But it's also 630 light years away from us and potentially a little bit hotter. This was actually assumed to be maybe Venus-like and not Earth-like. We also have some other candidates like Kepler 1606b, another super-Earth orbiting 2 stars, but these haven't been confirmed yet, so we don't really know if they exist. But in a nutshell, that's pretty much it. We essentially only have these 5 exoplanets orbiting in the habitable zone of G-type stars, stars similar to our Sun. And so finding a new planet is obviously super exciting. And that's essentially what happened here, except that this time it was discovered using a really intriguing method. A method referred to as TTV, Transit Timing Variations. And here this is somewhat tricky. We're essentially looking at very slight variations in orbit, which can usually happen because of one of 2 things. Either some kind of a second planet in the orbit of the star that changes the orbital parameters just a little bit every time the planet passes in front of the star, or possibly some kind of an exomoon that's pulling on the planet as its shadow passes in front of a star and as the shadow is being measured. And while obviously in the past, the transit method was how we discovered most exoplanets, but in some extremely rare examples, it was actually possible to discover other exoplanets by looking at these very minute transit variations. And in this case, this is a method that can help us discover planets that don't actually create a shadow in front of the star and that seem to have a slightly more inclined orbit. And the first time this method was used to find planets was back in 2012. This was used to discover planets in the Kepler-9 system. And because this method can be pretty accurate, it can also be used to indirectly measure the mass of the exoplanet, which is actually how the planets in the TRAPPIST-1 system had their masses measured over time. Here, this was done by measuring the transit variations, and by then using modeling in order to determine the overall mass for each of these planets. But this time, researchers were actually able to apply this to a slightly different star system, a star system similar to our Sun, and a type of a system that usually does not have a lot of these transits, simply because in most cases these planets orbit really far away. And so because of this major geometric constraint due to the orbital parameters, it's usually very difficult to find planets around G-type stars, which is actually one of the main reasons why so far no planet has been officially confirmed around the nearby Alpha Centauri. Alpha Centauri contains a Sun-like star and a K-type star. Both of them are pretty exciting, but so far none of them seem to contain anything. And that's because usually in G-type systems, or in Sun-like systems, transits are just too shallow and short-lived, and so it's very difficult to see them. But we knew that there was at least one planet here detected by Kepler back in 2016. And this was a planet extremely similar to Saturn in mass and potentially composition, except that it was orbiting much closer. It took approximately 40 days. So this is basically a kind of a hot Saturn. And so in this case, by analyzing the transit variation signals from the Kepler 725b, the researchers from the Chinese Academy of Sciences definitively confirmed another exciting planet. And here the accurate observations from the Yunnan observatories allow them to definitively determine the mass and the location of this planet. The mass once again makes it a super-Earth. This seems to be approximately 10 masses of planet Earth, making this one of the larger planets discovered in the habitable zone. But its orbit is approximately 208 days, putting it in a very similar position to Venus. And so here it's potentially also a little bit on the hot side, receiving at least 1.4 times more radiation than planet Earth. But it is nevertheless a really exciting planet, because this is basically planet number 6 orbiting a Sun-like star in the habitable zone. But even more importantly, by using this method, we can now start discovering additional planets, because this definitively demonstrates that by using the transit variation techniques, it seems to be quite possible to discover low-mass planets even orbiting in habitable zones of Sun-like stars, and even at these ridiculous distances of almost 1,000 light years away from us, which would be otherwise impossible using any other method. Mostly because these planets don't really show any other signs and are far enough from the star that they barely produce any shadow or even any pull on the star itself. And so here even the famous radial velocity method would be extremely challenging to use, especially because a lot of these stars are really massive and a lot of these planets are not. But if you look at this from a different perspective, this is only the 6th planet out of potential 11 billion out there. And so we're definitely just getting started. Hello info person, this is Anton, and today we're going to discuss a discovery of yet another somewhat strange exoplanet. An exoplanet that once again seems to be evaporating as a result of its star, but in this case is producing some of the most extreme emissions and some of the most extreme evaporation we have ever seen anywhere. In other words, this planet seems to be losing so much mass all at once that the scientists now believe it's going to be gone in approximately 2 million years. With this now being one of the most exciting discoveries when it comes to disintegrating planets, and a planet that's soon going to be examined by the James Webb in order to actually see what it's made out of. And so let's discuss this in a little bit more detail, but I guess let's start with the obvious. Approximately 5 years ago, such a discovery would be absolutely mind-blowing. But in just the last few years, researchers actually discovered quite a lot of similar examples of basically planets orbiting the star super close to the point where they start evaporating in their atmospheres, or, like in this case, actually their surface. And though the first such planets discovered were all gas giants, with one of the recent planets we discussed a few months ago basically being a gas giant that produces an enormous helium tail, in some of the more rare cases, scientists have also discovered terrestrial planets that already lost their atmosphere and are now just boiling and evaporating as a result of the distance to the star. For example, this discovery was a gas giant known as WASP-69b. But the evaporation in this case was not very fast. It was only shrinking by approximately one mass of Earth every billion years, and so this planet is probably going to survive for quite a long time. Likewise, there's another example known as HAT P32b, which is basically a hot Jupiter. Another case of a gas giant extremely close to the parent star that's very slowly evaporating its atmosphere, and specifically its helium, forming these really massive tails. But here once again this is a really slow process. It might take up to 40 billion years. And so when it comes to gas giants, these planets, despite evaporation, still have quite a long time to go. And in many cases they might even outlive the actual star. But out of approximately 10,000 different stars examined by the Kepler telescope, so far only 3 seem to contain terrestrial planets that seem to show signs of very slow evaporation. Basically here, instead of losing the atmosphere, they're creating a kind of a dust tail that's causing the planet to lose its crust and of course its mantle, and will eventually very likely destroy it completely. And extremely recently we've discussed one such example where the scientists finally confirmed an actual destroyed planet that seemed to have turned into a ring and caused the star to expand, as you see right here. And it was officially confirmed in a study only a few weeks back. You can find that video in the description. But compared to that destroyed planet, the previously discovered terrestrial planets that are being shredded apart all actually have quite a long time to go. One of the first known examples, Kepler 1520b, might actually survive for at least another 400 million years, with the other planet, KOI 2700b, very likely surviving much longer, several billion years. And the third example, K222b, may be disappearing in about 21 million years in the future. But now scientists seem to have discovered one of the most exciting such planets, because not only is it one of the closest, it also seems to produce the most evaporation and is also producing the biggest tail visible from planet Earth. But before we talk about the planet, let me briefly mention how scientists even know this is happening and how these observations are done. Just like with a lot of other exoplanetary detections, this is the result of the transit observations, basically looking at the planet as it passes in front of a star. And normally, in any star system containing different planets, we'll actually see an extremely similar dip that usually depends on the size of the planet and sometimes depends on the angle of passage as well. But when it comes to these evaporating planets, something else usually happens when this dip occurs. They basically very often look like fangs. Instead of being more or less equal on both sides, these dips usually have a somewhat long tail that can actually take several hours to complete, which in this case indicates that there's something else in the orbit of the planet, and that something is also blocking the star. And in this case, these residual observations were not always the same either. They actually fluctuated with every single orbit, which could only be explained if there was basically something coming from the planet, and it was always different with every single passage. An evaporating planet could definitely explain this. But because the actual orbit of the planet is approximately 30 hours long, yet this trail usually lasted for 15 hours, it implied that this trailing tail was at least half the orbit long, 9 million kilometers or about 6 million miles. And since it was producing a relatively large shadow in front of the star, this also implied a relatively high evaporation rate and most likely a somewhat low in mass planet. Much less massive than planet Earth, because planets like Earth, even at these temperatures, should still be able to hold on to their material without evaporating too much. And so by using 3D simulations, researchers established that this is very likely a Mercury-like planet, or basically an object that's about 4 to 5 times more massive than our Moon, that seems to orbit the star every 30 hours, and seems to lose Mount Everest amount of material with every single orbit. This is the highest evaporation rate we've seen so far from any planet. And so assuming that the mass here is correct, it's actually going to disappear anywhere from 1 to maybe 2 million years in the future, with the planet most likely eventually forming some kind of a ring around the star, but very likely avoiding the collision with the star just because all of this will happen pretty quickly. And so here the resulting event is going to be very different from what the scientists observed during the collision of a planet a few years back. And so in the end, this is just going to create a kind of a ring star until all of this material is blown away. But here the biggest question right now is, of course, what's exactly in this material? Because we know that this is definitely not ices and not even gases, as these gases and ices would usually evaporate super quickly. So wherever this is, it seems to stay in the orbit, even though it's so close to the star. Which is actually where the James Webb is going to help us in the next few months. Scientists have not observed the star and the planet with the James Webb yet, but once it's done, they're hoping to discover what this planet is made out of. And something very similar was already done for this other planet known as K2-22b, the other disintegrating terrestrial planet. Here, this is also a really small planet, possibly the mass of Mars or Mercury, and the observations from the James Webb in April of 2024 was able to reveal magnesium silicate minerals that's somewhat similar but a little bit different from what we find in the mantle of Earth. But intriguingly here, iron-rich minerals or iron-rich deposits were not discovered. But there was an unusual discovery of some kind of a gas, maybe CO2 or maybe nitrogen oxide. You can learn more about this in one of the studies in the description, but basically here this was an initial attempt at trying to discover the composition of disintegrating exoplanets. But unfortunately this signal was just not strong enough. In comparison, the signal from this planet is very strong. And so here it's quite likely researchers will know exactly what it's made out of and what seems to be inside this tail. Right now it's assumed to be something similar, possibly some kind of a magnesium-based magma with quite a lot of silicon inside that's boiling into outer space and is being removed by the radiation from the star. And because this is only 140 light years away from us, the observations here are going to be super accurate. And so right now the biggest question is, of course, so what minerals are we going to find here? Are they going to be similar to what we find on Earth? Or are they going to be entirely different and completely alien? Because for all we know, unlike Earth, which is technically an oxygen planet, this could be a carbon planet containing entirely different stuff. And so in terms of actual discoveries, that's unfortunately all we know for now. There are going to be more discoveries in the future, but there are obviously way more questions than answers. For example, one question that's somewhat difficult to answer right now is, of course, what kind of a planet was this in the past? Since it's evaporating so quickly, and since it's already lost such a huge mass, and also since it basically has like 1 billion years to go, we can only assume that it's been doing this for a very long time. And this is also a pretty old star. This star is actually older than 5 billion years old, and so if this planet existed in this region since the beginning, it must have been supermassive before. As a matter of fact, it might have been one of these hot Jupiters. And so could this be a typical hot Jupiter that evaporated very slowly over billions of years? Or is this something entirely different that accidentally migrated closer to the star in the more recent times? And if so, what exactly happened and how did it actually end up here?
Hello wonderful person, this is Anton, and today we're going to discuss one of the more interesting discoveries coming from two distant planets out there. And it's actually a discovery of something entirely new, but something that we always wanted to find. A discovery of planetary leftovers, and specifically, a planet orbiting so close to the star that it fell apart, disintegrated, and left behind a bunch of pieces for us to observe. But in this case, it's not even one planet from one star system. This time, researchers were able to analyze two separate planets in two separate star systems using two different telescopes, discovering something really intriguing in the process. And so let's talk about these two studies and these discoveries in more detail, starting with the studies themselves. First, a study by Nick Toussey and his team, focusing on a planet discovered by the Kepler telescope back in the days, a planet discovered to be in very tight orbit that a lot of scientists believed was probably falling apart. And then a study by Mark Hahn and his team focusing on a completely new planet, the planet whose name you see right here, that was actually discovered by the TESS telescope, whose purpose is to find new planets. But here something was really weird. The observation curves from this planet were so unique and so bizarre that we don't even see the planet itself, but instead we see its leftovers. And so I guess let's start with this planet first, because it is slightly more exciting. Now, TESS telescope, which is basically a follow-up to the Kepler telescope, is extremely good at identifying transiting planets. Or in essence, it's really good at doing this. And it's been doing this for several years. Now obviously it's already discovered thousands of planets, but in the majority of cases the observations were relatively similar. We basically get this very small dip in brightness coming from the star that usually has a very similar shape, indicating a planet passing in front of a star. And so relatively recently it once again reported on a new discovery, but the transiting curve was very unique. Now here's actually an example from the Kepler telescope of what this curve can usually tell us about the planet. For example, a super small terrestrial planet is only going to leave us with a very small dip, and it's going to be practically impossible to detect. Likewise, a planet passing the star only on the edge of the star is also going to produce a relatively sharp, almost like a V shape, that's though visible, has to be conferred many times. But then depending on the size and the location of the passage, we normally get different types of U shapes. In contrast, here's what the scientists saw here. And this was really strange because it was a shape that's never really been seen before and was never even predicted. And so once the analysis of the shape was conducted, researchers realized what they were looking at. So first of all, because only approximately 1% of starlight is blocked here, it implied that this was a really small planet, kind of like what you see right here, very likely a terrestrial world. And because it was happening every 30.5 hours, it was orbiting very close to the star. But here, with every transit, because the return to full brightness only happened very slowly, it basically suggested that as the planet passed around the star, it left a lot of stuff behind. Stuff that would actually block the star as well, essentially forming a kind of a ring around it. And that of course suggested that this planet seems to be shedding a lot of material, producing some kind of a cometary tail, and is basically forming something very similar we usually see around Saturn. For example, the Saturn's E-ring. This is Enceladus forming something very similar. And so because this was a terrestrial planet so close to the star, the temperatures here were probably pretty insane, very likely over 2000 Celsius. And that's hot enough to start evaporating rock, which is most likely what's happening here as well. The observations confirmed the existence of a relatively long cometary tail, very likely caused by a planet that's being evaporated. And because this is only 140 light years away from us, and because this was just discovered, it means that additional observations will very likely uncover some really exciting details. Right now, unfortunately, this is all we see. But even here, with further calculations, scientists discovered that it seems to contain two different tails: the trailing tail and the leading tail. Now, the longer trailing tail seems to extend for at least 9 million kilometers behind the planet, and very likely covers at least half of its orbit, whereas the smaller leading tail is possibly just over 1 million kilometers in length. And this is super similar to what we usually see around comets as well. But the formation mechanism is obviously quite different. But then, by simulating all of this, the scientists behind the study worked out the overall composition of these tails, in the process discovering that the leading tail, the longer tail, very likely contains sand-like particles, or basically larger particles, that also possibly contains a lot less density. Whereas the leading tail seems to contain much smaller stuff, basically size of soot or even smaller, that seem to accumulate around the planet and then extend a little bit ahead of it. And this allowed them to also calculate the average mass loss and even figure out how long this planet is going to survive. And here the mass loss is quite extreme. This tiny planet seems to lose 1 lunar mass every million years, which is actually quite a lot. And because this transit doesn't even show us the planet, it means that this planet is already pretty small, possibly size of Mars or even Mercury. And if this planet is that small, it means that it's going to lose all of its mass within the next 2 million years. So basically here we're finding a planet that's already almost completely destroyed. Naturally, this is also the first such planet ever discovered, and the first planet with such an enormous tail, but most importantly, the first confirmed terrestrial planet. Unfortunately though, the observations with the James Webb have not been conducted yet, so we don't really know what's inside the dust. But future observations, very likely sometimes in 2025, are going to tell us exactly what's inside this planet and what it was basically made out of. Right now though, it's assumed to be very similar stuff to a typical terrestrial planet. Silicates, some metals, and possibly either a lot of carbon if this is a carbon planet, or oxygen if it's a planet similar to planet Earth. But James Webb was actually used to discover something very similar around a different planet that we already knew is falling apart from a few years back. So this is that second study. And here, K222 seems to contain a much larger planet, but also orbiting in a very tight orbit, that was also confirmed to do something similar, but where we now have very detailed observations from the James Webb. Here, this planet orbits every 9 hours and seems to have a temperature of 2100 Kelvin, and that's hot enough to even vaporize iron. And initially, scientists did expect to see some kind of a mantle composition, possibly silicates and metals, or maybe even discover some kind of a bare iron core. But unfortunately, the observation in this case was not really perfect, which made the interpretation a little bit more difficult. And that's because during these observations, the planetary tail was extremely dense and did not return very good data. Nevertheless, they still found certain things that were definitely there. Here this is visible as 4.5 and 5.1 microns of infrared radiation. And that's carbon dioxide and nitric oxide. Stuff that we usually associate with things like icy objects and comets. And not something that we expected from a mantle or from a terrestrial object. And that's actually a little bit bizarre. Or maybe not bizarre at all, depending on what exactly this planet was. Because here it's quite possible that this planet was actually some kind of a really large icy object that migrated from somewhere entirely different and is now just falling apart and being shredded apart because it cannot exist so close to the star. So essentially here this might have been some kind of an ice giant or maybe even just a smaller ice planet, similar to some kind of a Neptune or mini-Neptune that contained a lot of stuff that comets are usually made from. With this discovery also suggesting that we might find something very similar around the previously discussed planet 2, for one reason. There's a very important similarity between these two star systems. They're both binary stars. And so the orbital dynamics between these two stars extremely likely is the reason why these planets spiraled inward and ended up orbiting one of the objects. In binary systems, getting a prominent orbit around a star is extremely challenging, which is why most binary stars discovered so far don't actually contain that many planets. Most of them very likely got destroyed in a very similar way. And the presence of ice around this planet suggests that it very likely formed on the outskirts, and its orbit eventually got disturbed enough that it moved closer and closer until it started to evaporate. And something similar might have happened around the newly discovered BD plus 05 star system, implying that this is probably an extremely common phenomenon. Here the scientists refer to this as hurling snowballs at each other. And that also suggests that we might discover even more of these unusual planets or disintegrating planets in a lot of other binary systems as well. As a matter of fact, one of the explanations for why the nearest star system to us, Alpha Centauri, doesn't have any planets is maybe right here as well. Or right here. It's basically the result of binary system interactions that eventually result in all planets being absorbed into one of the star partners. And sometimes in the future, we might even find leftovers of these planets either on the surface of one of these stars, or possibly as some kind of a leftover, such as an asteroid belt resembling a ring. Either way, these are really exciting discoveries and really exciting observations, and since only 4 such planets have been discovered so far, ever since we started looking for planets, this is actually a pretty big deal. But we now have James Webb, and so in the next few months we'll probably find out what the smaller planet in this case was probably made from, and if it had a very similar story. Ice giant coming close, falling apart, and basically disappearing.
Hello wonderful person, this is Anton, and today we're going to discuss a discovery that was actually made back in 2019, but it basically took 5 years to officially confirm. A discovery coming from a star system approximately 635 light-years away from planet Earth, and a discovery that demonstrates the incredible technology we now possess to see objects really far away. And as you can probably tell from the title, it's essentially a discovery of an extremely distant moon. A moon around an object you see right here known as WASP-49b, a distant Saturn-like planet that seems to possess a volcanic moon potentially very similar to Jupiter's Io, a moon very likely covered in a lot of different volcanoes, but a moon that finds itself in extremely unusual, very hostile conditions, and whose existence is maybe not very easy to explain. And so let's talk about this discovery in a little bit more detail, and more importantly, discuss how all of this was even confirmed. But first, let's briefly discuss exomoons and what we know about them so far. Now naturally, based on the observations from the solar system, we kind of expect a lot of exomoons out there. For example, as of today, over 300 moons have been already confirmed in the solar system, with almost every planet out there possessing a moon. And because moons tend to form naturally even around asteroids, it's fair to assume that we should be finding a lot of these very likely around most exoplanets we've discovered so far. But the problem is that unlike finding planets, finding moons is exceptionally challenging. Not only do they basically produce almost no shadow when passing in front of a star, they also don't produce much wobble, mostly because their masses are expected to be very low. And so as a result, discovering exomoons have actually been a bit of a challenge. In the last decade or so, there have only been a few candidates and nothing officially confirmed just yet. For example, one of the more popular ways to try to find these objects is by using various transit methods. One example is what's known as transit variation method, or transit timing variation. It's essentially when you look at the star and you see these transits of a planet, but every transit happens at slightly different times, as if something was shifting the planet just a little bit. And this is actually how some of the exomoons have been potentially discovered before, but the problem here is that these transit variations can also come from neighboring planets that could be hiding in the star system. And so, as a result, nothing official has been confirmed yet using any of these observational methods we normally use for planets. Okay, maybe not entirely true. There's actually one example, based on gravitational microlensing method, that did witness one object, specifically a rogue planet, that potentially had a moon. But because this is technically a rogue planet, the moon around this object is a little bit different. In a sense that it's not really an exoplanet, because it's just not orbiting any star. But there's definitely at least one example. Although in every single case, with every single detection, there are usually alternative explanations that usually make just as much sense. And so as a result, as of mid-2024, there have not been an official confirmation of any exomoon out there. And that's maybe until, I guess, now. Here we get a very unexpected discovery based on the observation of gas emissions, and specifically emissions coming from this hypothetical moon. And so here, by observing this for a very long time, it's actually been almost 7 years now, scientists discovered that this unusual object, and specifically this planet, known as WASP-49b, seems to contain a really large gas of sodium in orbit around this planet. Now this is, as you can see, a relatively hot planet because it's really close to the parent star. As a matter of fact, a single orbit here takes just over 2.8 days. But as far back as 2019, when I actually made the first video about this, scientists were able to see this unusual cloud around the planet, suggesting something was orbiting it, and suggesting that something was spewing out a lot of sodium. Now because in this case this is a gas giant, similar to Saturn, and also because it's orbiting a G-type star similar to our Sun, first of all this was actually a really exciting star system, because it was kind of Sun-like, but second of all, since these objects are mostly made out of hydrogen and helium, there was no mechanism to explain how so much sodium could be produced around the planet. And while we know quite a lot about these sodium emissions from the solar system, here's actually a really intriguing image by Dr. Sebastian Voltmer that shows us the emissions from Mercury. It actually makes Mercury appear as some kind of a comet, but in reality this is sodium escaping the surface of Mercury, visible from far away. And similar shells exist around other planets, but naturally they're not always sodium. But for a typical gas giant to have something similar, there's just no way to explain this. We don't actually know of any mechanism that would suddenly release sodium from a planet like Saturn or Jupiter. And because nothing similar has been discovered around other similar objects, this was obviously a very unique discovery. But because this is science, we still had to have more evidence, as right now this was just a hypothesis. Maybe because this planet was so close to the star, there was some kind of a mechanism that allowed for this to happen. And technically, it wasn't even just sodium. It was also additional metals, including magnesium and iron, which did suggest something unusual happening here. And a lot of these initial observations started to also confirm that none of this was gravitationally bound to the planet, and was potentially escaping into the outer star system. But there was one example we could use from right here in the solar system as well. We know for a fact that Io releases something very similar, but in much smaller amounts. And we know that Io does produce a sodium tail, visible from very far away, which even creates certain effects in Jupiter's magnetosphere. So for example, in these observations by NASA, you can definitely see the sodium ring produced by Io around Jupiter. And when it comes to Jupiter, some of these clouds can expand so much they are even 1,000 times greater than the planetary radius. And so a similar mechanism was expected here as well, because for some reason something was producing 100,000 kilograms of sodium every single second. And if this was from a planet or a star, there was really no way to explain it. But like I mentioned, it took 5 years to confirm this. And the best evidence came from observing how this gas moves. For example, here in the first observation, we discovered that this gas clearly increased in size, as if something was producing more gas at certain points, because maybe of some kind of a major emission. A volcano in this case would definitely explain it. But much more importantly, this seems to have happened some distance away from the planet. So basically, it would be very difficult to explain this if it was not a moon. But a much stronger evidence came from the observations of the velocity of the gas as it orbited the star. Here, sometimes it appeared to be moving a little bit faster than the planet, in a way that it appeared to be orbiting the planet at a distance. So almost exactly the same to what we see around Jupiter. And so even though the planetary atmosphere was moving in one direction, this gas was actually moving in the opposite direction. And if it came from the planet, it would make absolutely no sense, which essentially provided enough evidence for this to be a volcanic moon around a distant Saturn-like object. But an extreme moon that we've never seen before and cannot even imagine. Here, a single orbit only took approximately 8 hours, and that's on top of the planet orbiting the star every 2.8 days. Intriguingly, having this orbit means that this moon is almost at the edge where it should not be a moon anymore and should technically become rings. For example, for Saturn, the D ring orbits every 5 hours, the C ring every 7 hours, and the B ring every 8 to 10 hours. So by having a moon so extremely close to this planet presents us with a bit of a mystery on how exactly can it exist and what exactly is this moon made out of. Obviously, if its density is really high, it's going to be able to survive much closer to the planet, but at the moment nobody knows. And so in this case, for all we know, this is actually some kind of almost like a terrestrial planet-sized moon with relatively high density, but extreme conditions on the surface. And since it's losing so much mass every second, due to the squeezing from the planet's gravity and the effects from the star, at some point it's most likely going to completely disintegrate and might actually become a ring system after all. And so right now this is actually one of the more intriguing discoveries, not only when it comes to exomoons, but just actual discoveries in astronomy. A mysterious moon that's kind of difficult to explain, and that seems to produce very similar effects to what Io does around Jupiter. But at least for now, that's all we know. Hello InfoPerson, this is Anton, and today we're going to discuss a somewhat intriguing study in regards to white dwarfs, and specifically a study that actually discovers evidence that some of the most exciting habitable exoplanets might actually exist around white dwarfs and not other types of stars. And there's maybe even a chance that at least one of these planets has already been discovered. And so let's discuss this in a little bit more detail, but obviously let's discuss white dwarfs first and what we know about them so far. Now naturally, most of the stars in a galaxy at some point are going to become white dwarfs. That's basically what's going to become to our sun and approximately 97% of all stars that are out there right now. So basically hundreds of billions of years in the future, when there's no more star formation, the majority of stars in the Milky Way are most likely going to be white dwarfs. And here we're talking about hundreds of billions of them in the entire galaxy. But naturally, as the stars evolve into becoming a white dwarf, and as stars like our sun go through their red giant stage, they destabilize the entire star system, but also very likely destroy some of the planets while forcing other planets to relocate somewhere else. For example, in the solar system, today we believe that Mercury and Venus are most likely going to be destroyed completely. Earth may survive, but it's not clear, and planets like Mars, Jupiter, Neptune, and Uranus are extremely likely to relocate and potentially come closer to the star. And many of these planets will probably collide, many of them will probably be shredded apart, with some of them forming various rings around the white dwarf, but some of them also very likely leaving remnants. And in the last decade or so, there's been a lot of research about this, and a lot of evidence for the existence of various objects around white dwarfs. And the most common type of the phenomenon is referred to as the polluted white dwarf. And that's basically the detection of various elements on the surface of the white dwarf that very likely came from various planets, suggesting that the white dwarf consumed quite a lot of these objects. Right now, anywhere from 25 to even 50% of all white dwarfs seem to show different metals on their surface, basically pieces from various planets. But of all the discoveries, and here we're talking about thousands of white dwarfs, only a handful of planetary mass objects have so far been confirmed. Mostly because they're much more difficult to detect and much more difficult to find. But there's also been some really exciting discoveries that clearly show us that a lot of activity happens around white dwarfs, with many white dwarfs potentially actively destroying planets, actively consuming them, or possibly building them up. For example, this object seems to have experienced some kind of a catastrophe around 2010. It also very likely contains different clouds and even various comets, and there's even been signs of asteroids in this system. Likewise, another object you see right here seems to have experienced regular dips and a lot of chaotic activity, suggesting something was in orbit or something was disintegrating in orbit and eventually disappeared. And WD 1145+017 was also really surprising because of its unusual dips and transits, but then these transits suddenly disappeared. So here there was something really large orbiting it, and it either relocated somewhere else or potentially got destroyed. And so here we have quite a lot of evidence that a lot of white dwarfs still have quite a lot of planetary activity around them, and very likely still have an ability to even form planets, possibly from a lot of these remnants. As a matter of fact, even the James Webb Space Telescope was recently able to discover at least 2 white dwarfs that seem to contain relatively large planets at a slightly farther away distance. Although here the planets were slightly farther away, at a similar distance to where Neptune is in the solar system. But the evidence from all of this is pretty much the same. There's still a chance for some white dwarfs to potentially host a planet that can actually migrate into the region where the white dwarf can create habitable conditions. And in the last decade, quite a few studies try to focus on this and try to find out if it's even possible. Here's at least one study you can find in the description that investigates the idea of having habitable zones around white dwarfs, discovering that for an average white dwarf, very similar to what our Sun is going to become, not only do these zones exist at approximately 0.012 astronomical units, but they also remain completely unchanged for at least 7 billion years, implying that in many cases, many of these white dwarfs can actually have very stable habitable conditions in certain regions, or at least implying that even white dwarfs could have planets with thick atmospheres and water-rich environments. And so for the past 10 years or so, there's actually been quite a lot of attention on this topic, focusing on potential habitable exoplanets around white dwarfs. Except that maybe there was one small issue. A typical white dwarf also cools down over time. Okay, here we have to briefly discuss how white dwarfs generate energy and why they're still hot. Inside the white dwarf there is no more nuclear reactions, but they can still create quite a lot of energy from residual heat, and in many cases their temperatures can be pretty high. As a matter of fact, some white dwarfs can be over 100,000 Kelvin in temperature. And so because they're usually extremely dense and contain a lot of mass in a relatively small volume of space, they can also contain a lot of this residual heat. As a matter of fact, most of them will be cooling down for almost 1 trillion years. But as they cool down, obviously their habitable zone also shifts just a little bit. And so for many of these white dwarfs, as they cool down, some planets that might have been in the habitable zone before, after a few billion years, will now be a little bit too cold. But turns out that there's actually a special case of white dwarfs where this doesn't seem to happen as much. And it's this special case that was explored very recently in a study you can find in the description. And here this refers to an extremely specific type of stars, only identified like 5 years ago, referred to as Q-branch stars. This was actually discovered by the Gaia telescope completely by accident. But here these are white dwarfs that are usually a little bit more massive than the Sun, but strangely enough seem to pause their cooling for at least 8 billion years. In other words, instead of continuously cooling down and thus moving their habitable zone, these white dwarfs tend to do something like this. They seem to maintain conditions and seem to not change much for a very, very long time. And it took a few years to finally explain why and what exactly is happening here. Now this only happens in about 6% of all of the white dwarfs, but it seems to be a result of what's known as distillation, and specifically based on things like neon-22. This is a very neutron-rich isotope that sometimes can be found in some white dwarfs, and so in extremely high temperatures we get a formation of crystals that then actually rises to the top, sort of like water ice rising to the top inside liquid water. And these buoyant crystals then push down the neon-22 atoms, sometimes forcing them out of the crystals and making them move to the bottom of the white dwarf through the process of distillation. But because this reshuffles the interior of the white dwarf, this also releases a huge amount of gravitational energy. And because this is a relatively slow process taking billions of years, it essentially ends up producing relatively constant heat that makes these white dwarfs very stable for billions of years. Although here, for this to work, this white dwarf has to have at least 2.5% of neon-22 by mass, which, as I mentioned before, seems to happen in at least 6% of all white dwarfs, which by itself actually gives us quite a lot of hope, even though 6% is not a lot, because we expect most of the stars to be white dwarfs in the future. That still means we're going to have billions of stars that will very likely have a high chance to have these long-term habitable conditions, with at least some of them maybe hosting planets in this region. And in some cases, these white dwarfs are expected to maintain these conditions for at least 10 billion years. That's over twice as long as what Earth got in a solar system, thus giving these objects a very high chance to potentially host life, or at least have permanent habitable conditions on the surface. In this case, because these white dwarfs are a little bit more massive, these planets will have to orbit at approximately 0.03 AU away from the star, or about 3% of Earth's distance from the Sun, which currently is actually thought to be possible. As a matter of fact, this white dwarf surprised everyone a couple of years ago, when something unusual was discovered passing in front of this object every 25 hours. Now here this could be something moon-sized in terms of size, possibly an exoplanet, and right now it's not entirely clear what it is, but if confirmed this would be the first exoplanet discovered in the habitable zone of a white dwarf, although here this white dwarf is not one of these neon types, so the habitable conditions here are a little bit different.
Hello wonderful person, this is Anton, and today we're going to discuss a somewhat surprising discovery of an extremely young planet. Actually, the youngest planet we've ever seen, and discovered completely by accident because it was basically peeking through some of the dust that usually covers early stars. And though by itself this is already an exciting discovery, it also explains a lot of things about planetary formation and presents us with some new explanations. And so let's discuss this in a little bit more detail. And let's start with some of the previous assumptions about the idea of how planets form. And here we know that everything starts with a protoplanetary disk. In the last few decades, researchers have seen a lot of different examples from a lot of different telescopes, such as the ones you see right here from ALMA, and they all present us with a relatively similar story. The story of gas collapsing into a ring-like object, which then flattens, forms an overdensity in the middle that eventually becomes a star, but also forms different types of planets, many of which have been discovered in a lot of these disks. But in most cases, any planetary objects inside these very early disks are either brown dwarfs or still developing and undeveloped planets that are essentially just blobs of gas that one day will collapse and become planets very similar to Jupiter. And by observing different star-forming regions, such as the famous Orion Nebula, researchers have pretty much discovered every major intermediary stage, from the early stages of the collapse of the gas, to the stage when these disks start to develop, to basically already developed disks that are slowly losing all of this extra material, becoming more and more transparent. But when it comes to planetary formation, researchers have always believed that it should take at least 10 million years, or maybe even longer than 10 million years, depending on the explanation and the theory behind planetary formation. In other words, depending on the explanation involving star formation and involving planetary formation, different research papers explain this in slightly different ways. But one of the first breakthroughs when it comes to planetary formation was discovered in 2014. This was an object known as K2-33b, an extremely young super-Neptune, or basically a planet more massive than Neptune, less massive than Saturn, that was orbiting a very young star, pre-main sequence star known as K2-33. This planet was confirmed in 2016 and it was actually discovered by the Kepler telescope during its second light mission, which is why it's known as K2. And so at a distance of just over 150 light years, this was a super exciting object because it was only 9.3 million years old, basically confirming that planets can form within about 9 million years, because in this case this was seen to be a fully formed planet, no longer a protoplanet and no longer just a blob of gas, but a protoplanet that still contained an early atmosphere that was basically slowly evaporating. And so one of the main reasons this discovery was so important is really because this planet was kind of bizarre. It was extremely close to the parent star, but was also extremely young. Here, a single orbit was only 5.5 days, and this planet was receiving 125 times more sunlight compared to Earth. And here, even the atmospheric analysis suggested an already developed atmosphere, including carbon monoxide and even organic compounds. And so by discovering this very young planet, several theories of planetary migration could be automatically ruled out, mostly because it just took too long for this planet to migrate from farther away, with a much more plausible planetary formation scenario basically involving a little bit of travel, or possibly no travel whatsoever, implying that this planet somehow formed very close to the star. And this naturally provides a few clues about the solar system and how various planets formed here as well. It also suggests that similar planets could have existed here and then eventually disappeared with time. Once again, because this is such a young system and because this planet is so close to the star, there is actually a chance that at some point it might get swallowed. And for many years this was the youngest, and I guess one of the more unusual planets known to us. And that's of course until now. The new study by Madison Barber and her team confirms a discovery of a 3-million-year-old planet with the name Tidy 1b. Tidy is actually an acronym for Test Investigation Demographics of Young Exoplanets Project, with this being the first planet confirmed by the project. But here this was discovered completely by accident, and mostly because of a strange quirk inside the disk. Here this disk is also just 3 million years old. And just like with other disks, normally it would be practically impossible to see anything inside. But here, by complete accident, this planet is slightly misaligned with the disk, making it escape the disk once in a while. And so even though in most cases these planets would be completely hidden by the dust, here, because of the slight tilt, which by the way is one of the mysteries here as well, because nobody knows why this tilt exists, scientists behind this paper were able to observe minute periodic dips in brightness every 8.8 days, basically suggesting that this is another compact orbit planet that seems to orbit very close to the star and also seems to be some kind of a super-Earth or a sub-Neptune very similar to K33b. Actually, a type of a planet completely missing from the solar system, but a type of a planet that seems to exist in many star systems out there. These are technically some of the most common planets discovered to date. And because it usually takes at least 5 million years for these disks to dissipate, discovering something in a 3-million-year-old disk is obviously super exciting. If it wasn't for that bizarre tilt, it would never be found. And well, so far, based on the analysis, we know that this planet is relatively large, possibly 10 times bigger than planet Earth, so essentially this is once again some kind of a Neptune-like object. But intriguingly, unlike K233b, here it still seems to have primordial atmosphere, including a hydrogen envelope that will eventually disappear, dramatically decreasing the mass and transforming this planet into something entirely different. As a matter of fact, possibly something similar to the planet I showed you previously, with one implication here being that in just 6 million years, the enriched hydrogen envelope will completely dissipate, transforming the planet into something a little bit more solid. Although in this case, just because of the distance to the star. But once again, because it's so high in mass, and because it contains so many volatile compounds, it possibly formed somewhere farther away and possibly migrated here, eventually coming closer to the star, which is maybe why its orbit is so tilted. There might have been an interaction with another object, or maybe even a collision, that dramatically reduced its orbit. And here the migration explanation is currently preferred just because of the mass of this planet. We've never seen so much mass present in any early star system so close to the star. Although just to clarify, in this case the mass is just assumed. We only know its size because it was discovered using the transit method, which is of course the method involving observing the shadow of the planet as it passes in front of the star, and so for all we know it's a lot less massive, thus presenting a new mystery because its density would be super low as well. But the size here seems to be very similar to Jupiter, which does suggest a massive object. And because it's so large and also because it's located in an easily observable environment, this is now a perfect target for the James Webb. Because it's so large and because of its low mass, observations with the James Webb Space Telescope are going to reveal a huge amount of data, especially because this is pretty close to us. It's located in a famous molecular cloud known as the Torus, one of the closest star-forming regions, approximately 500 light-years away from us. And so in some of the future studies, by analyzing this planet and by discovering how exactly it formed, we might actually finally have some definitive answers about planetary formation in general, and thus explain how planets in the solar system formed as well, and I guess more specifically, why they're so different from everything else we've discovered in other star systems. As we've discussed before, for some reason, there has not been a single discovery out there out of thousands and thousands of different star systems that seem to have very similar structure to the solar system, where there are basically 4 terrestrial planets, 2 gas giants and 2 ice giants, or really anything with a similar arrangement. We either find star systems with a lot of gas giants, or a lot of terrestrial planets, or usually something in between, super-Earths, mini Neptunes, but never something similar to the solar system. And so at the moment, this has no explanation. But by discovering these very bizarre objects like Tidy 1, we might finally have some answers in the next few years. And so until then, and until future discoveries, check out some of the previous videos on similar topics in the description. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.